Hello. Mic test.
Good to go? All right.
Thank you. Let's get started. Apologies for delay. Welcome to the session, and I'm Binu Ramakrishnan from NVIDIA, and I'm going to talk about building trust at the edge, lessons learned. The work I'm presenting is broad in nature, and there are many people who contributed to this effort. So I would like to take the opportunity to acknowledge their contribution and grateful to be here because of the teamwork. Here is the agenda and outline what we are going to cover in today's session. We'll start with a brief introduction to edge computing, and we get into the threat modeling, attack models, and motivations. And we introduce the building blocks, which is used to orchestrate security at the edge. And we end the session calling out some of the challenges which we encountered as part of the journey. How many of you are security practitioners here? Okay. All right. Edge computing. What is edge computing? Edge computing brings compute and storage closer to the sources of data, and it allows applications. It enables applications that require ultra low latency, high scalability, and high throughput. In our case, our application provide AI inference at the edge. So it enables applications like AI inference to process data in real time, conserving network bandwidth and saving the response time. So if you look into the overall architecture, the one what we are describing from edge computing perspective, we have a cloud layer which is used to manage or a fleet of edge devices which are deployed at the edge. And the primary reason that edge nodes are deployed closer to the sensor is it will allow the edge nodes to do real-time processing. Examples of edge computing includes retail, shopping malls, airport, hospitals. The edge computing combined with AI expected to transform industries from retail to healthcare, manufacturing to smart cities. And many of these edge systems are mission critical, and industry largely underestimate the critical need to provide highest level of security for the applications running in these at this edge. Before we dive deep, let me try to categorize the edge computing models to broadly into two. One is the edge appliance, and the another one is edge platform. And what we are covering today is the edge platform. And the edge appliance provide end-to-end experience. It is mostly purpose-built, and it is capable of doing predefined set of functions. And the data collected from the sensors are processed by typically trusted applications. Whereas in the case of edge platform, it's a generic platform that allow or support wide range of applications such as manufacturing, retail, and healthcare. It is relatively powerful machines. For example, can run applications such as AI inference. The fundamental difference here is the data is processed by the customer deployed applications rather than the trusted application directly from the provider itself. You can think the appliance more like a vertical build-up versus edge platform is more of like a horizontal build-up. Here's a reference edge node stack. We have hardware, firmware, and on top of that we have Linux, Kubernetes, and all the applications which are running as a pod in this Kubernetes cluster. I understand that each edge stack differ. You may not be using Kubernetes. You might be using FreeBSD instead of Linux. And in our case, we support both x86 and ARM. However, this talk is more focused on x86. We are still working on the ARM side of things. But the overall, many of the things what I'm going to discuss will be applicable to any edge systems. Here's a variation here. Here you have an edge system that is BYOD. It's basically bring your own device. You buy the device, you hook it into a system and use it. So as you can see here, it creates unique security challenges. For instance, who is responsible for keeping the firmware up to date? In the case of x86, the UEFI lockdown, so and so forth. So it creates some challenges from a provider perspective. I will get into those soon. Here are some assumptions and scope. The assumption here is we have a cloud-managed edge platform service, essentially a cloud-based service that manages fleets of edge nodes which are deployed in the customer location on the remote sites. The scope here is the edge node deployed in the customer premises. So and we are approaching this from a platform or service provider perspective. And what is not in scope is we are not going to talk about cloud security. That could be something we can, that will be a topic for some other time. Likewise, we're not really talking about the security of the IoT sensors. Edge security, what level of security is desired? Where do we draw the fine line? It largely depends upon your business model and your risk appetite. Like I mentioned, if you can get into a appliance mode where which is probably relatively easy to secure, but you will provide a fixed set of functions. Whereas in the case of a platform, you are essentially providing a general platform which have more security consequences. The other factor include whether it's a purpose-built hardware or you are entertaining bring your own kind of device. So all those things can impact the security threat landscape. To secure edge system, we first need to understand the threat landscape. Who are the threat actors, and what are their motivation? How do they attack, and what is the impact? The threat actors include nation-state actors. Those are the group either funded or supported by government agencies around the world. And organized group are, they provide, in short, cybercrime as a service or command and control as a service. The other group, very minor but still disgruntled employees and hacktivists. Hacktivists essentially they champion for certain cause and indulge in these kind of activities sometimes. Their motivations steal data and intellectual property. For nation state, stealing is primarily to achieve some security strategic objectives, versus organized group primarily do that to make some money. Ransomware, they lock you out and demand ransom. Steal compute resources. Once the machine is compromised, let's say sometimes these computers are powerful enough, and they'll make it part of their command and control. They often use for crypto mining and things like that. And denial of service, that is another aspect here. For example, activists can really disrupt it. They don't really gain out of it, but it can really create chaos in the system. Attack models, how do they attack? There are physical access because this is the edge system. And remote, since this is connected, over the network attacks are also possible. Vulnerabilities. Vulnerabilities are everywhere. Any non-trivial piece of software have defects, and some of them have security consequences. So attackers always look for opportunity to exploit these vulnerabilities in the system. Hardware and software supply chain. The attackers trying to do some backdoor either in hardware or software, and trying to gain access to these edge systems. What is the impact? Depending upon the industry, for example, if it is a healthcare, there could be risk to life and disclosure of PII and other sensitive or confidential data. Financial loss, litigation, losing market to a competitor, impacting your brand, and it can disrupt services, causing chaos in your system. Imagine Friday afternoon in LA City, all the traffic lights goes off same time, and you can imagine what can happen. Things like that. Here are some additional considerations here. One is the physical accessibility. This will lead to unauthorized physical access these devices. The other scenarios include it is susceptible to side channel attacks such as timing attacks, power consumption analysis, cold boot attacks, things like that. And since they have the physical proximity, you can also mount firmware. It can basically modify firmware and exploit any firmware vulnerabilities. The another factor is heterogeneous hardware. It is mostly the bring your own device kind of scenario where you are there are so many vendors here, and that significantly increase the attack surface. And likewise, there is no real standardization in the pre-boot environment, especially in the firmware world. Different vendors support different kind of tools. That is also something to consider. The third one, again, is related to the bring your own device, shared responsibility of the edge nodes. As a provider, we need to trust the customer, and the customer, you're expecting customers to lock their UEFI, lock their firmware, patch the system in time. So that's another thing to consider. There is to build security, we need to identify the security building blocks. And a security building block is a unit of technology, process, or a combination of both. In this slide, I'm introducing the building blocks, which is used to orchestrate security. And there are, I just call it out. The one is the hardware root of trust. The trusted computing base, firmware security is very important here. Identity, authentication, and authorization, secure edge, enrollment, encryption and data protection, remote attestation, runtime and boot time integrity, threat detection and failure reporting, supply chain security, vulnerability management, and over-the-air update, and defense in depth. We will cover this topic in next few minutes. Root of trust and trusted computing base. In the diagram in the right shows how the chain of trust is established from boot to the runtime. And there are two complementary technologies here. One is the UEFI secure boot, and another one is the TPM or Trusted Platform Module and the measured boot. Here you can see the secure boot use the UEFI as the root of trust, and measured boot use the TPM as the root of trust. What is secure boot? Secure boot ensure that the node boot only using the software trusted by the provider, and if any of the software that is part of the boot chain is compromised, then the signature match will fail, and the system will not boot. So it is more of a hard fail. Whereas in the case of measured boot, we have in the TPM we have something called platform configuration registers, which basically is used to store a cryptographic measurement or a hash of each of the software layer in the boot chain. IMA or integrity measurement architecture extend the measured boot to enforce runtime file integrity. The TCB, it's not from a strict sense, but mainly from a broad sense. This is a set of, this is a stack we need to defend against. We need to make sure that the integrity of the stack is protected. Yep. So TPM is a separate topic, but this is a brief, a 30-second intro to TPM in case if you are not familiar with the TPM. A TPM is a coprocessor on a motherboard which is capable of doing or generating secure random numbers. It can generate keys and hashes, and it can also use to store cryptographic keys. And it can also do cryptographic operations such as RSA and AES operations. And one important thing, at least more relevant for us, is it provides platform configuration registers, essentially a set of registers around 25 or so, 24 I think, that is used basically to store some hashes which measured boot use. And it is used for performing attestation. And one thing to note here is this device is passive, and it is a very, it is a pretty slow device actually. Secure boot and measured boot I already covered, so I would skip here. But the main thing here is in case of secure boot is more like a hard failure. If any signature of any of the component in the boot chain fails, then system will fail to boot. Whereas in the case of measured boot, it will compute the hash and update or append those hash value in the TPM PCR registers. And it is passive in nature, but it requires an external service to attest these measurements. Yeah. Edge node enrollment. You have a device now. How do you securely introduce this device to the service provider? Imagine you as a customer, you bought a device. What is the process there? There are multiple ways to do that. I'm just describing one way, and there are a lot of variations possible. In simple terms, the way it works is you have an account with the service provider. For example, the same way you have an account with AWS, GCP. So you have that account. Now when you're ready to register a device, what you have to do is you go to the web console, whatever the provider provide, and say, I want to register it. So one method is they provide some kind of a token, one-time, short-lived kind of token. Say, oh yeah, here's the thing. You just go, you take our software and deploy it in your edge node, and you also pass this one-time token. And internally, it install the software as part of it initialize the TPM, generate the TPM keys, and it register the TPM key with the edge through by passing both OTP and the keys associated with the TPM. The, in the end, what happened is the edge system knows that, okay, oh, this is the edge node, I know that, and this is how I can authenticate with that edge system. And the TPM protects cryptographic keys and operation and prevent attackers stealing keys and key cloning, essentially. When we talk about edge node, it is not just one application. There will be multiple applications running in edge node. Likewise, if you talk about the cloud, there are multiple applications running there as well. So how do they communicate with each other? And we need to have a strong authentication in place to communicate with these systems. And how do we do that? Let's talk about node identity. So you'll be thinking, yeah, we have a TPM-based identity, so we can use that to authenticate with cloud services. Yes and no. It works in some case, but it cannot be used. There are some issues here. It is easy for the edge agent to connect to the edge node manager because they already have the TPM's public key. But that is not the case with many other services in the cloud where the edge wanted to communicate. That means you cannot really communicate beyond or to any other service other than the service that has the TPM's public key. Imagine you are a provider which is managing hundreds of nodes or thousands of nodes. Managing these keys is also a little difficult. I mean, you need to spread across or share these keys with many services. So to remedy the issue, we introduced a cloud authentication service or token service. What it does is it actually do the authentication with the TPM, and it issues a OIDC compliant JWT, and any service, and that is a short-lived or ephemeral, and any service that is compliant with the OIDC, it can make it work. Again, you don't have to use JWT. You can also use ephemeral certificates and things like that. Here is one example here. You can see the edge agent request TPM to sign. You can see that edge agent is making a request to the TPM to sign the node token, and it make a request to the OIDC service token service, and the token service authenticate and know, oh, this is coming from I know this edge, and I know it is a legitimate request, and it will issue a short-lived OIDC token, and all the subsequent connection from, say, edge agent to edge management service, they can use this OIDC, and through OIDC discovery, this service can authenticate the token and allow this edge node to access the services. Alternatively, step 1 and 2 can be replaced with mutual TLS with the TPM backed key using PKCS 11 interface. Let's talk about remote attestation. It is a complicated concept, but let me try to explain. The array is a mechanism array is a mechanism used by the service provider to verify that an edge system connecting to itself is booted with trusted software. Let me discuss about one scenario here. Here, the edge. Imagine the edge system booted up. The first thing they do is you try to connect to the service provider's the cloud service, essentially, and the cloud service say, hey, yeah, I know you are Edge Bob. I know you through the TPM key, but I do not know whether you are booted with a trusted software. Let's do this. I give a nonce. you just go and get a PCR code. So the edge system take the nouns and contact the local TPM and say, hey, generate a PCR code for me. And what is a PCR code? PCR code is nothing but a PCR measurement signed by the TPM's attestation key. And and the PCR code and an event log sent back to the edge manager. Hold on. Platform configuration registers. Yeah, it's a TPM construct. It's basically provides set of registers where you can only extend the value. You cannot really modify it. I deliberately not going into those details because those are kind of another topic. So, but I hope you understand the larger context. So where did I stop? So the PCR, the value upon receiving the PCR value, you just compare with a reference value and see whether that matches. If there is a mismatch, you saying something? Okay. If there's a mismatch, then what happens is it trying to parse the event log and see where the mismatch occurred. This diagram is not really good, but please bear with me. So how do we get the reference state? That's an important thing. You can get it by different means. One way here is, remember I showed you the node enrollment process where the system is actually booted first time. So as part of the process, it's basically get the measurement at that stage and consider that as a reference code. It is more like a trust on first use kind of model we following, but there are other variations possible. If you know your hardware well, then you can also know what will be the value at that stage. As a runtime extension to attest, so we can actually extend it through IMA. It will support the runtime integrity check. The IMA, what it provides is the file integrity check. Like you can basically hash the file, and any of the files modifies, and then we can enforce, or at least we can detect that okay, this file has changed in runtime. Can you be loud? We use TLS. The PCR values are signed by TPM at private key, so we cannot manipulate that. Okay, let's we have a Q&A so we can discuss, and if I can also sync up with you offline. Yeah. So data security, data protection is critical, and whatever data we are storing in the edge, it has to be encrypted. This will protect when the drive is stolen, repurposed, or reused. Data in transit, we need to make sure that whatever data transmitted over network is protected. TLS is a recommended protocol there. TLS is very critical, not just for securing the data, but it is critical to protect against man-in-the-middle attacks. It's very important. Secure deletion of data if the drive or NVMe is retired or repurposed, then we need to make sure that the data is cleaned up. Network. Punching holes into customer firewall to allow inbound connections to edge services is easier said than done. The problem here is the customer network. They have their own IT policies, and some organizations are pretty big, and they have separate organization to manage those things. And if you want to open, let's say, some firewall ACLs, it may take ages to do that, or it may not even happen at all. The recommendation here in this kind of scenario is since generally firewall generally allow outbound connections, particularly like ports like 443. So always initiate connection from the edge device. That way you can really reduce the dependencies. And it's also good practice not to run any services or listeners, specifically network-based listeners on the edge nodes. Just reduce attack surface area. Runtime integrity and threat detection. For edge platform, threat detection is an important function, and such systems are required to detect and alert anomalies that occur in the system during runtime. Here are a few rule set examples. Reverse shell. We can have a rule set basically to identify reverse shell and reverse DOS. Reverse DOS is someone getting to the edge node and trying to mount a denial of service in the local network. The another thing is you have a pod, which is imagine it's a web server. It's only if you see you can have a rule set to detect any kind of bash exec. So that's I'm just giving some examples. If you know the certain patterns, you can update your rule set to detect certain CVEs, for example, like log4j, log shell kind of vulnerabilities. You can detect brute force SSH, crypto mining. We can track the outbound request and see where it is going, and depending upon the IPs, we can determine if it is a crypto mining happening or not. Then we can also track based on Stratum protocols usage, which crypto miners generally use. We can also tag certain files and see if anyone touched that, and we can get notification that will help to prevent data exfiltration. Supply chain. Software developed in recent times heavily rely on open source components. Besides the security of the software we built, open source security of the open source also have a direct impact on the edge. The fact is that any non-trivial software contain vulnerabilities, and some of them has security consequences. We have both hardware and software security risk. When you talk about hardware, we have what is that? Interdiction and seeding. Interdiction is essentially you are modifying in transit from manufacturing to the end user or the consumer, whereas seeding is you're putting some backdoor as part of the manufacturing process itself. And the software side of things, there are many ways to compromise third-party packages or third-party or open source libraries, like compromising GitHub accounts, updating, making changes, things like that. So what are all things we can do here? You have to source these packages. You have to be careful. And if possible, if there is an option not to use, then don't use it. Every It's not open source is not free. It brings a lot of liabilities to your stack. Um, and you scan, as a best practice, you scan for vulnerabilities, looking for CVEs and malware, etc. Secure distribution of whatever artifacts we build. That's important over TLS recommended. Publish checksums. There are some new advancements here on image signing, SigStore. I don't know if you're familiar with that, but they offer tools for signing and verifying software. It is good for container signing at this moment, but there are a lot of other artifacts as well you need to consider. Build supply chain provenance or some kind of attestation of the build process, attesting the SBOM and things like that. In Toto and Salsa, those are the two options in this space. Again, those things are in these early stages. Vulnerability management and over-the-air updates. Vulnerability management is a continuous function to identify and patch vulnerable packages in a timely manner. And OTA, or over-the-air update, is a vehicle to update or patch these edge systems. And OTA happens in this following condition, not necessarily a full list of things, but in general, like remote attestation failures. Whenever we do remote attestation, remember, like, there is a PCR code comparison. If any such failure happens, it get alerted, and they may determine, hey, there is some bad happen, we need to re-image the system. Sometimes it require physical presence, or sometimes you can do over the air. Likewise, if we identify some vulnerability in some of the packages as part of our stack, then we will do a OTA. Regular upgrades generally go through the OTA, and other reasons include some kind of security attacks or something we identified as part of our threat detection system. Sometimes we use OTA to update. Note that the OTA may change some of the PCR measurements. So we need to make sure that we are updating the reference state accordingly in a reliable manner. It's a little challenging, but it's possible. So all the things which I discussed, the building blocks, those are the big things, but that is not the end. But there are a lot of small but important steps we need to do to make the system secure. I'm listing out a few, but there are many more. From authentication side, we generally recommend use of ephemeral tokens and certificates. We should have a RBAC for customers, remote console for device administrators if you want to manage the edge device from the cloud. Isolation, we have a host and application level isolation. We can enforce that containers can run in an unprivileged mode. And between applications, we separate using Kubernetes namespaces. Operating system, we have to harden the operating system. It's very important. We use a SysCat as a reference. In addition to that, we also do other things. For example, we strip down the OS to make it as small as possible. That way, it will reduce attack surface and also reduce the need to patch the system because some of the unused packages may have vulnerabilities, and we end up patching the system. We can avoid that. Read-only file system for system partitions and encrypted data partitions. Some examples here. And hardening of the Kubernetes cluster, enabling RBAC policies, and provide admission controllers to enforce certain policies. The policies include you can run only as a particular unprivileged user, you can only open certain ports, only certain inbound, outbound are allowed. You can also apply AppArmor policies, SecOm, things like that. It can also use the the SIG store which I shared previously. It also provides some, can also use admission controller to basically verify the Docker container images, signed container images. We have dedicated namespace for customer workloads. Those are things you can follow. So if you're listening, this probably be the most interesting slide, I would say. This is basically show all the things which we discussed, and it just show how all those things are mapped and connected. If I describe it, we just converted into 3 phases here. One is post deployment, what all steps we have to do, and then another is during the deployment phase. Then the third one is pre-deployment, post-deployment, where some of the runtime controls kicks in. In the pre-deployment, we're talking about third-party software and what all things we do there. We talk about applications, native applications which we build, what all things we do there. Talk about Kubernetes, what all things we do there. And operating system, very important component, what all things we do there. And there are many things, some nuances. I excluded that just for clarity, but so all these software are built and put into some artifact factory, and we can potentially provide some integrity, like you can publish checksum hash, you can sign those artifacts. Those are some other things you can do. Once the system and you can see here the user basically pull the software from the provider's artifact repository, and you basically install that in the edge. And at that stage, you will do pre-boot protection like UFA lockdown and secure node enrollment. Those are some of the activities part of the deployment. And when you talk about the runtime, we have the runtime protection, we have runtime detection. Runtime detection include TPM attestation, Falco eBPF logs, then secure boot, and runtime prevention include immutable file systems, Kubernetes namespace isolation, admission controllers, and the trust. We depend upon the TPM and the UFI, TPM backed identity, TLS, CA bundle. So I hope this will be helpful for you to visualize all the things which we discussed. Challenges: building trust on disparate pieces of hardware and software provided by a variety of vendors is an uphill task. Here are some of my observation on issues came across as part of our journey. Secure boot, it is cool, but remember it is hard failure. If something bad happened, you just stop booting up. That may not be the thing you want, because you have a cloud service which is monitoring or supporting edge device, and if the edge device is not even coming up, you don't even get an opportunity to see what went wrong. From that perspective, it will be better to have measured boot than secure boot. Both are better, but secure boot, other problems include you have custom kernel modules, or unsigned, you have to use some unsigned third-party modules. So how do you manage that? You need to update the UFI database that require physical presence. So those things can create more trouble. And stability of the TPM PCR bank, we come across the values are not consistent between hardware providers. Like sometimes it's just changing. Even the, for example, the BIOS PCR bank 0, uh, not supposed to change, but sometimes just reboot just change. Uh, so things like that. Um, and lack of standardization in firmware, pre-boot environment is another thing we have to deal with. There are some Redfish API, all those things are coming up, but I think it has to evolve, I think. Supply chain attestation is it in early stages, and I believe it's not ready for a wide adoption yet, but that is something to watch out. Uh, Artifact signing package checksum work. It's easy, simple. Container signing is doable now, but signing and verification of other artifacts currently it's not trivial. Uh, so with that, it's a teamwork, and that's it. Yeah.
Couple questions, like your Jetson,
Mhm.
ARM,
It's ARM based. It is ARM
does
based.
that also have, it doesn't have UEFI or that, it doesn't have.
No, no, no. The ARM, we are currently working on a solution to work on Jetson.
Okay, then that circuit doesn't have a TPM in it.
We are considering a firmware TPM,
Okay,
but still
all right,
early.
I'm working with potentially two of your, integrators. Do you know if either of them has a Eon or Syslogic? Do they include a TPM in their integration? Do you know? You ever heard of those manufacturers?
No, maybe let's talk offline. Yeah,
Okay,
yeah,
all right.
yeah, sure.
Sorry, I have a basic question because I'm not a hardware engineer. So when you talk about the trusted, the root of trust, you talk about the TPM, and then above that level, there's the secure boot and UEFI firmware. Do you have to have both, or did you pick just one of those?
Are you talking about?
The very first thing you talked about, the root of trust.
Yeah, so if you are using secure boot, you have to rely on UEFI, root of trust. But if you are not using secure boot, you don't have to rely.
Okay, so you just talked about secure boot. There's some problem with it. If it dies, the whole thing dies. Is
So
that
secure boot, it is a hard failure, right? You have a boot chain.
correct?
Now you are starting your application,
Yeah.
and imagine one of the component in your boot chain is compromised or something happened, and the signature there's a signature mismatch. At that time, the system won't boot.
That's what you want. I don't want the system to boot if it has been compromised. What's wrong with that? I'm sorry. Maybe I'm really out of my culture. So you may not be compromised.
Yeah,
That's the problem.
yeah,
Oh, I see. Okay, you can't troubleshoot it. Oh, it's just dead. Oh, I see. So do you guys use secure boot? I have no idea what's going on. For that same reason we just talked about. Oh, what? I'm sorry. For the secure, okay, so, but definitely everything has TPM, right?
Not every device does that. You need to have this hardware in the new device. It's like saying, does every device have a TPM? No.
Okay, so our laptops, does it have TPM? I don't know.
Recent ones.
Okay, got it. I'm sorry, I just don't know hardware enough, but thank you for that, because I just care, I care.
Read on this is the curious flow. Something by the booth. Yeah, it's like the guy who does secure read on Linux. Do you have like contact to offline?
Uh,
By the booth or anything?
yeah. Let me conclude this. Yeah,
Sorry.
yeah. I'm just yeah, yeah, yeah.
All right. If you install the system agents, it requires a kernel module, and they don't have a signed version of the kernel application. Right? Right? I'm infuriated by that. It's 2 years.
All right, okay, thanks a lot. That helped a lot. I like the group discussion because I'm kind of lost. All right, thank you.
Yeah.
We all started somewhere.
No, when you talk about hardware, that just, I do security control on the application side of it, but now I'm really interested on this kind of stuff because it looks very complicated.
Uh,
Well, that chart looks complicated, yeah.
I didn't mean to make it that way, but it ended up that way.
Okay. What did you say? You didn't mean to make it that complicated?
It ended up that way, yeah, when I started charting out. But I still, if you pay attention, it's not very complicated. Uh, yeah, when you see first time, maybe you get overwhelmed. But if you just look through that, probably it'll be not very hard. Uh, yeah.
Picture again of like what a use case of this would be, this architecture, and like what is the
Which one? This one?
control and what is the provider control?
You're talking about this one or something else?
I mean, this what you've been presenting about Edge.
What I'm
Information is untrusted.
no, what we are presenting here is some of the experience on building an edge system, an edge platform, and some of the patterns we can use across. Oh, you're talking about the use case. Okay, I think I described as part of the edge computing introduction. Uh, one use case here is imagine one simple use case I can tell you, like the AI inference. You have an edge system that can process live traffic feeds looking for traffic violations. That's one example. And you can use this edge system in the factory floor as a robot, and it can do some AI inferencing, the robot. That's another use case. And there are so many use cases related to edge AI inferencing. These are like two examples.
Also, like SaaS point of sale, having an edge device is different than
Yeah.
In retail. And so which part of the edge device is like, you know, belongs to the provider that's providing the edge cloud or edge service, and where does the customer?
The customer, at least in our case, get uh, an approved kind of device from OEMs, which provide this approved device, and they bring it in, and they plug it in. Yeah. Uh, the,
They buy the appliance, they install it on-prem, and then they talk to you with their application.
Or the alternative is you build a cloud, you run an application for your partner, that then you do data processing for them at a mid-tier site. They just buy a license.
yeah. This is more of a generic platform. That means we can fit into different kind of application, different industries, and we have verticals built on top of that for various verticals. So I just only covered the platform. Uh, yeah, we are on time. Let me. Uh, any more questions before I can wrap? Okay. Uh, yeah, go ahead.
The only thing I don't see is like the assumption here is edge device or node will not have any kind of BMC bare metal control.
Oh, I didn't. I deliberately excluded that because that is another another.
You can actually
Uh, BMC, I didn't really add it here, but yeah, if BMC is another thing, we need to really protect that. But that's where the network side of things become very important, because BMC security is primarily the network security. If network is not secure, then you are kind of compromised. Uh, all right, I'll be around today and tomorrow, so if you have any questions, if you want to have a conversation, feel free. Thank you, and have a good rest of the day.
Cool, so I'm gonna go ahead and get started in just a second here. Actually, I think I'm gonna use the restroom since I had a ton of caffeine as I finished this presentation on the car ride here. So since I don't want to piss myself in front of you guys, I'll be back in just a second.
Act like we didn't know this. We just played off. Very cut. I'm missing the opportunity. No, think I will. So easy doing like this.
All right, so I'm gonna go ahead and get started. My name's Alex, and today I'm gonna be telling you guys the story of how I accidentally made a hardware business at 18. So actually, just last week, I was at the HOPE conference in New York, which is Hackers on Planet Earth, and I gave basically the same presentation with just about the same amount of preparation as well, which was starting the presentation a day I was supposed to give the talk, a day before I was supposed to give the talk, working on it all the way up until the last 5 minutes, as things happen for me. So, my name's Alex Lind. I'm an open source hardware developer and also a cybersecurity content creator. So I'm usually making education-focused content on the Hack5 YouTube show. If you guys aren't familiar with Hack5, they're a cybersecurity vendor that creates products for pen testing, red teaming, and that sort of thing. I mostly create beginner-focused content where I create walkthroughs, tutorials, that kind of thing. But more recently, I've been focusing on hardware and physical attack exploits. And I'm going to be showing you guys one of the tools that I developed today that I've been showing off in some of my more recent demonstrations. So when I'm not creating content, I also create more maker-oriented content on my personal blog where I have walkthroughs for different hardware stuff that I make. I create various projects like the one I'm going to show you guys today. But my primary interest is in low-cost microcontrollers and ways that you can use them for low-cost hacking, like Wi-Fi hacking, signals intelligence, and that sort of thing. So just an overview of what this talk is going to be about. I'm going to be telling you guys my backstory. Sorry, I'm a little out of breath. So I'm going to be giving you guys my backstory and telling you how I got to the point where I am today. I'm going to be telling you a little bit about the business that I started completely by accident. I'm going to talk to you guys about the ideation process of the product that we're now selling, which is called the Nugget. It's a cat-shaped circuit board. And I'm going to tell you guys about some of the mistakes and key things that I learned in the development process of this product. So hopefully, if any of you guys are product developers or makers, you won't make the same mistakes that I made or that we made along this process. So what is the Nugget? The Nugget is the project that we've been working on over the course of the past year. It's a cat-shaped circuit board that's designed to teach beginners about cybersecurity and hacking. So we currently have two splits of this product. One of them is focused on physical attack vectors like USB hacking, keystroke injection, and that kind of thing. And it has a little gamified interface that walks you through the process of running some of these attacks. So it's really great and beginner-friendly. And we also have another version of the Nugget designed for Wi-Fi hacking. So this one's more oriented towards things like network defense, running Wi-Fi attacks. And it's a great little walkthrough for beginners who are just getting started in these areas. In addition to that, it also comes in a pretty easy to put together kit that you can solder together yourself. So this has been a centerpiece of some different soldering/hacking workshops that I've been doing over the course of the past year. And it also makes for a great beginner programming tool, and it supports some languages like Python and Arduino and stuff like that. So I'm basically just going to be telling you guys about how this product was developed and also some areas where we screwed up. So first I'm going to start with a little background about myself. So I first started getting into hacking and programming, I would say sometime around 5 years ago in middle school when we were issued TI-84 calculators in math class. And if there was anything I wanted to be doing in math class, it sure as hell wasn't math. So I taught myself how to program on this calculator, actually with a built-in interpreted language called BASIC. So I taught myself how to create like bitmaps and like games and stuff like that, and I started selling it to other kids at school. But once I got kind of bored of that, I looked into some more hardware stuff, like how I could actually hack the calculator, like overclock it and add Wi-Fi so I could create like a mini IRC channel to communicate with some of my friends in class and some crazy stuff like that. But eventually when I got bored of that, I would say sometime around the summer between middle school and high school, I learned about the Raspberry Pi, which was a low-cost microcontroller or microcomputer for $35. And that really piqued my interest because growing up, I was kind of poor. I didn't have a computer at this point. But seeing that there was something so accessible and so cheap that I could learn hacking on, this was really interesting to me. So I picked up a Raspberry Pi. I started learning about Linux. And sure enough, I discovered that there were all sorts of interesting things. There were all these different distributions that you could use for specific applications like Kali Linux for hacking and all this cool stuff. Still catching my breath. So I eventually taught myself how to do stuff on the Raspberry Pi. And one of the very first things that I taught myself how to do was actually hack Wi-Fi. So as I said, I grew up kind of poor. We didn't have any internet growing up. So when I had to do schoolwork, I would basically have to skate over to Starbucks, use their Wi-Fi, and then go back home. And then just sit in silence. So I eventually taught myself how to hack Wi-Fi so I could have that from home and be able to do my schoolwork and that kind of thing. And I eventually started teaching myself how to do some other stuff like programming and that kind of thing. But I found it kind of frustrating that there was just a lack of general documentation on the internet for some of the stuff that I was trying to teach myself. So eventually I created a YouTube channel where I started documenting various tools that I was learning. I started documenting walkthroughs of how to set up various Linux tools, that kind of thing, for other beginners that were out there. And here you can also see one of the first Raspberry Pi-based projects that I worked on called the Audit Pi. But getting my start in Wi-Fi hacking really piqued my interest just about that general subject with signals intelligence and that kind of thing. So I started trying to teach myself a little bit more about that. And that's where we get to the very first signals intelligence project that I worked on. So the first, So the first project, the first independent project that I worked on that actually had some contribution to the project that I'm going to be showing off today was called the Creep Detector. So this actually used the little handheld device that I made here called the Audit Pi, which is focused around a Raspberry Pi. In order to, basically what I wanted to do with this was showcase a way that an everyday person might find signals intelligence or Wi-Fi hacking or that kind of thing useful. So the project that I ended up coming up with was, what if I could create a device that allows you to determine if maybe a creep or a pervert is stalking you? So the way we did this was we used a signals intelligence technique called word driving, which is basically where you can drive or walk around and map the physical location of Wi-Fi devices around you. We used that technique to determine if basically the presence of a Wi-Fi device like a cell phone or a laptop or something like that was spotted at multiple unique coordinates along the route that you were traveling. So this is one of the very first projects I came up with on the Raspberry Pi. It was a combination of some different Linux tools and also Python, and the demonstration ended up working. So that was really cool and rewarding, and this was a project that I worked on with my friend Cody, who I'm now running this business with today. So while I found working with the Raspberry Pi very interesting, I wanted to get into things that were a little bit easier to get started with and also more low cost. So this is where my interest for microcontrollers developed. Microcontrollers were really cool. They were really cheap. These are things like Arduino Nanos, the Espressif line of chips, AT-Tinys, Atmegas, that kind of thing. I thought they were really cool, and I saw some research out there on how these could be used for more hacking-oriented stuff besides just like developing. So I thought this was really cool, and I wanted to find ways to integrate this into the signals intelligence research that I was doing. I didn't really know where to start. There wasn't a lot of great beginner documentation on using some of these microcontroller platforms for hacking, so I didn't really get into that until I would say somewhere around like my sophomore or junior year. I got this crazy-ass commission from this guy who wanted me to create a device for him for tracking down a cell phone that he lost in the forest. So I had no experience with creating anything of that sort, but I was poor, I wanted money, this sounded cool. So I said, great, I'll take $300 and give me maybe a month or two and I'll have something for you. So I started looking into how it would be feasible to do this, and I built off my previous research with the Creep Detector project to also use signals intelligence in order to track down his lost cell phone. So the way that this worked is I built this platform around a microcontroller that we'll look at in a second called the ESP8266. It's about, you can find them for like $1.80 on AliExpress, maybe $5 on Amazon. But basically there is a library that allows you to do promiscuous Wi-Fi sniffing, and you can look for a particular type of Wi-Fi packet called a probe request. So even if you turn off your phone, not if it's completely shut down, but if it's just like turned off and left somewhere, your phone or other Wi-Fi device is still going to be emitting a type of packet called a probe request, where it's basically looking for networks that it's seen before and constantly emitting this out into the air. So I thought, what if I could program this microcontroller to look for that specific packet, have it hone in on the signal strength of this device, and then use an antenna to be able to track down the physical location. Well, it turns out that crazy-ass idea worked. He was able to not only find his phone, but he was able to find multiple cell phones that people lost in a local river. So he lived near like a resort or something like that, and he would go rafting quite often. But it turns out lots of people brought their phones there in like waterproof bags, and they ended up like dropping them. Also at this point, I was still poor. I didn't have a cell phone, so I was like, hey, do you mind sending me one maybe? So that's how I got my very first phone from this random guy on the internet that I made this crazy device for. ESP8266. I have a picture of it in an upcoming slide if you want to take a look. But yeah, all of this is relevant because this is how I got my background in signals intelligence and also microcontrollers. But I was really interested more in the low-cost aspect of being able to do these kinds of attacks. So anyways, I was doing all of this sometimes towards the end of high school. I was getting like occasional commissions and that kind of thing. But I found myself at a point where in my senior year, I discovered that I was one of my only friends who didn't apply to college. So at the very last minute, I was like scrambling to put together these applications, and then I realized I don't really want to do any of this. I don't understand why I'm applying to college. This isn't really what I'm looking to do right now. I'm more focused on like, it just didn't really speak to me. But also I didn't really have an option to, like stay home or something like that because my home life sucked. So I tried to start a personal brand called Lind Labs, which is my last name, where I tried to advertise basically the services that I would commission, which was creating custom hardware, software, web apps, and stuff like that. That wasn't enough to sustain me or be able to move out from my crappy home situation. But as it happened, the friend that I worked on that previous project with, the Creep Detector, he was creating cybersecurity videos for a company called Hack5, which is where I now create videos for. And he also ran a live stream on a different channel called Security Forward. But he basically said, hey, we basically are in a struggle right now to produce content. So if you want to come out to Montana for just 2 weeks, that's where they were. They moved out there during the pandemic just because it was like kind of hectic here. He said, hey, if you want to come out to Montana for 2 weeks, create a bunch of content for us. Maybe you can stack up a couple $1,000s, move back, and figure out what the hell to do with your life. So I was like, oh, great, that sounds cool. I'll make a little bit of money, but I still don't know what I'm doing in terms of college or if I'm going to move out or what. I think I lied to my parents and said that I got into UC Santa Cruz or something, and that after I was going to come back that I would go there. Spoiler alert, those 2 weeks ended up becoming a whole year that I ended up staying there. And then also, just another side thing, my friend was previously working on a little project with a friend that didn't end up working out so well, so he had a ton of extra, just like random hardware components on hand. So he was like, hey, while you're here, if you also just want to help me come up with a design so I can get rid of all this extra hardware and maybe sell it on the internet or something, that'd be cool. So what ended up starting out as a fun little project also became the high-intensity startup that we're now running today and dedicating most of our waking active hours towards. So it's quite grueling. So this was the initial thing that we came up with. So my friend had he had a bunch of leftover screens, he had some buttons, and then he also had a Wi-Fi microcontroller that we're going to look at in upcoming slides. So what we ended up coming up with was this design, which you can see is sort of akin to the probe hunter that I showed in a previous slide. So I said, hey, why not just slap this all on a board, and then we'll sell it as maybe a soldering kit. We can teach classes or something like that, put it on the internet. I don't know. It was just kind of a random idea. We just wanted to get rid of this hardware. We didn't really have a focus for this. It wasn't really a product that we wanted to bring to market. So just as a joke, we decided to slap some random graphics on there. We decided to call it the Hack Cat. We put a little cat boy on the back. We have a little cat emblem. So that's where this all started out. So now this brings me to my next point, which is the first lesson that we learned pretty hard. And this is why all-in-one hardware platforms suck, or more specifically, why hardware multi-tools suck. So we didn't know this going into developing this product because we weren't even looking to design something that we wanted to bring to market. We just wanted to basically dump all of our components into this design, sell it all on the internet, and then be done. So the first reason, in a second I'll get more into the actual storyline of how this product was developed. Also, let me check the time. Okay. So the first reason why I think this sucks, and this is also a pretty common mistake I think that a lot of makers and product developers end up making, is initially it seems like a great idea to create like an all-in-one multi-tool to try to appeal to basically everybody. This is a tool that does everything. Who wouldn't want this? I think this sucks for a variety of reasons, but the first one is you're the only one who actually truly understands how to use this product. Like as you can see here, I think I found this design on Tindy. It's supposed to be like a Wi-Fi multi-tool with like a screen and temperature sensor and like a bunch of other random crap, but who knows what the hell this is? It's kind of crazy. So this brings me to the first case study, which is my own personal project, the Probe Hunter. So let's analyze why this kind of sucked. So initially it started out as a single purpose design for tracking down Wi-Fi signals. That was really cool. But once people on the internet, after I started publishing this design, started gaining some interest in this, I tried to make it do too many things. I started slapping on an SD card reader, so maybe if you wanted to save Wi-Fi packets to it, you could do that. A GPS module, so if you wanted to do war driving, it could do that. And then eventually it just became this general purpose Wi-Fi reconnaissance multi-tool IoT embedded project that does everything. And no one was attracted to that. It was a piece of crap. Nobody bought it. That being said, while I do think multi-tools suck, it's important to know who you're developing the product for. So if you are creating a design and it's for yourself as a product developer or a maker or something like that, I do think there is some value to adding extensibility and modularity. So for example, one of the other products I worked on, this was also a pretty crazy ass idea. I seem to attract that sort of attention, it seems. But some guy who worked at a gas station wanted me to create a mesh network, a cryptocurrency mesh network that detects when truckers pull up to the gas station and then automatically incur a charge to their Bitcoin wallet, so that way they don't have to physically get out of the truck. So it was a pretty crazy idea, but I was like, hey, if you're gonna give me money, I'll do it. He ended up sending me $2,000, so I was like, that sounds sick. So I wish I had a demonstration of what these actually did, but I thought it was so crazy I never bothered to document it. But these were some of the nodes that I ended up developing. And the underlying circuit board actually reuses my Probe Hunter design. So in this case, a multi-tool is kind of useful if it's just behind the scenes, and it's just for you as the developer. So in my case, since I knew what I wanted to do with it, and since the customer just wanted a polished product and never had to see what was under the hood, that was an okay application for it. If I was trying to sell this as a general purpose multi-tool, not so much. So this was the microcontroller I was talking about earlier, which serendipitously turned out to be a great design choice. So this is the D1 Mini. It's a particular form factor of the ESP8266. So you can see up here, there's this little Wi-Fi chip on this board. That's the ESP8266. It's a really cheap, low-cost Wi-Fi microcontroller that you can use to do things like develop embedded products that do Wi-Fi stuff. But what's also really cool about this is it has some great applications for Wi-Fi security. You can do things like Wi-Fi attacks, such as deauthentication, so you can kick people off their Wi-Fi networks. You can also use it for gathering reconnaissance to see when your, I don't know, your pervert neighbor is home based off the presence of their cell phone. But when I was developing the Probe Hunter platform, I chose to go with this particular form factor since now that I really wanted extensibility in mind and I thought I was going to create a multi-tool for everybody, it turns out they had a bunch of these different modules that you could just stack directly on top. So that way, if you wanted to add a temperature sensor or another SD card reader or maybe a battery module, it was really easy to do that. And I thought this was something that consumers really wanted. So I ended up designing around this platform. And that's also the chip that we happen to be using in our current design today. So that worked out. One example is this D1 Mini war driving rig that I created. So if you guys aren't familiar with war driving, I think I explained it kind of briefly. But basically what it is it's a technique where you combine Wi-Fi and GPS. So you can drive around and map the physical location of Wi-Fi devices and pin them down to a GPS coordinate. So this little creation here is basically just the D1 Mini with the SD card module stacked on top in order to log Wi-Fi data hooked up to a GPS. But in this particular case, I forgot where I was going to go with this slide. But in this particular case, we were able to use this for some cool demonstrations, such as war flying. I ended up actually making a video on the Hack5 show, if any of you guys are interested, where we wanted to see if we could physically pinpoint the location of one of our friends in like a 5-mile radius by just flying a drone over for like 20 seconds around a huge park, and we were able to actually use this to triangulate like their exact location. But anyways, back onto the point of why hardware multi-tools suck. Let's take a look at a case study from the company that I'm now sort of working for, which is Hack5. So Hack5 creates very specific products that have, well, Hack5 creates pen testing products with a very specific purpose, and they generally have a single use case. So I think this is great because with a clear-cut purpose, it's kind of hard to get wrong. It's kind of hard to get the idea wrong of what these products are supposed to do. And although some of them might have alternate uses, that isn't the main selling point, so it's kind of hard to confuse beginners. I'll get more into that in a second. But for example, these are some of the devices that Hack5 sells, and each of them has a very clear-cut purpose depending on what kind of engagement you're getting in. For example, if you want to hack devices over USB, you'd probably go with a USB rubber ducky, which is a keystroke injection tool. If you wanted to do man-in-the-middle attacks, you have the plunder bug. You can plug this into your phone to read packets, plug into Ethernet, and you can sniff people's traffic. If you see an open Ethernet port in the wall and you wonder what it's connected to, you have the Shark Jack. You can just plug it in, it runs Nmap or some stuff like that, and then is able to give you that data back. If you want to get into Wi-Fi hacking, they also have a product for that called the Wi-Fi Pineapple. So it's all very clear cut, and it's sort of I would call it like a portfolio business model, where each of these has a very specific purpose, and they're not trying to appeal to everyone. So it's really easy as a beginner or even as an advanced user to determine which of these products you want to pick up. And it's also not convoluted and crazy like my other ideas. So this brings me to my second point, which is beginners want to feel smart. So how many of you guys have seen this product or heard of the Flipper Zero? Cool. So actually, for some of you guys that don't know what that is, I'll explain it in a second. But this is actually an example of a multi-tool that I think fell a little flat, unfortunately. So the Flipper Zero is basically it's a multi-tool for sniffing a variety of different wireless protocols. It can also do stuff like physical hacking, so it has like these little breakout sensors that you can hook up to custom modules. You can do sub-gigahertz sniffing. You can do stuff like open up garage doors. You can maybe clone someone's badge that they tag into work with. You can open up Tesla charging ports. You can do all sorts of cool stuff. It's meant to be a general purpose multi-tool for all sorts of hacking. Actually, I'm going to go more into this point. But basically, this thing was marketed as a multi-tool for everyone. And I think where this design actually fell a little flat was the fact, well, one thing that they did get right actually was that it's supposed to be a friendly, intuitive design that's meant to attract beginners. You can see it's a gamified interface that has like a cute little dolphin that guides you through like how to hack different things. It has like a little D-pad that's in a Game Boy-esque style. But they really like ramped up the advertising on this one. And when they actually delivered it to the audience that they were trying to sell to, I feel like it fell a little flat in terms of the actual documentation for beginner use cases. Some feedback that I've been getting on this device, we do a weekly live stream where we just basically ask people about like any hacking questions or what tools they think is cool or not. One of the biggest pieces of feedback that we've been getting on this particular device from people that bought into this hype was that they pick up this product, it looks cool and all, but they don't really know how to use it. There's not beginner documentation on the actual hacks that they can do with it, and it's more of the advanced audience that actually knows how to use this tool, which is really unfortunate. But this brings me to the point that you really have to know the target skill level that you're trying to appeal to if you're going to create a device. If you're trying to sell to beginners, you don't want them to feel let down when they buy this product. I feel like a lot of people bought this expecting that it would be easy to figure out like a really cool hacking project to do with. But then they were kind of let down when they didn't really know how to get started, and resultantly they put it on the shelves and felt kind of stupid. Of course, that's not the case for everybody. Some feedback that we got from some advanced users who have this product is that they felt like it was packing too many things in one product, and typically advanced users don't really want that because it's kind of limiting to have like an all-in-one thing that isn't particularly good at everything, if that makes sense. So that was another key mistake that we made. We didn't know any of this going into designing our product, because as far as we were concerned, we just wanted to get all this crap out the door, sell these extra components, and that was that. So here you can see the first design that we worked on that was called the Hack Hat. That's basically the board we just slapped all these components onto. But the thing was, we didn't really have a big idea. We didn't know who we were selling to. We didn't know who the audience was. We didn't know our target skill level or any of that. But what we decided the best thing to do was basically widen the pool and make this a thing for everybody. This is a tool for everybody. You want to learn how to solder? You can do that. It has a microcontroller that supports Arduino and CircuitPython. So you can use existing community stuff that's out there in order to interact with that board. And that was kind of a lazy approach, just leeching off existing resources. But I'll talk about more of that in a second. So in addition to that, in order to widen the pool that we were trying to get rid of all this hardware to, we also came up with this crazy paperweight of an idea, which was called the Long Cat. So it was basically a longer form factor, and it had a battery on the bottom, so that way you could now carry around your portable paperweight. But then, as a joke, I came up with the idea for the Nugget. So since we were sticking to a cat theme, just because my friend really liked cats, I said, hey, what if we came up with a conference badge kind of thing where it's actually shaped like a cat? And there's some existing community projects out there that we'll talk about in a second, but one of them was called the Wi-Fi deauthor. So this was actually the project that my friend was initially working on that ended up flopping, but the software was still out there. So I said, hey, why don't we run this on this Nugget board, and we'll see if any people are interested in this design. Sure enough, this one ended up becoming a hit, and the other ones, not so much. This is also the deauthor project as it is today. So to clarify, we don't develop this product, but the deauthor is basically a software tool for Wi-Fi attacks that runs on that microcontroller I was talking about, the ESP8266. So it serendipitously worked on our platform. But you can see that developer that things didn't end up working out with is now creating some of these other crazy designs like the deauthor watch and also that thing in the corner. Yeah, so this was the initial design. This is where it all started. So we drew that pretty crazy whiteboard drawing that is pretty akin to the actual design we have today. And then we have this crazy ugly board design that I literally pulled out of my ass in like 5 minutes. And then for a rejected design for obvious reasons, we have the Wi-Fi penis, which we also called by some other pretty nasty names that I won't repeat right now, but if you want to ask me at the end of the talk what that is, maybe I can tell you guys. So at this point, it was more of a design experiment to see which of these 3 designs would sell better. So we had the Wi-Fi Nugget, the Hack Hat, the Long Cat, but the Wi-Fi Nugget is the one that ended up sticking at some point. So the first month into developing this product, fortunately, we made the decision that developing all 3 of these platforms at the same time was a terrible idea, so we decided to focus specifically on the Nugget instead. Still, we had no clear idea what this product was actually for. It was just sort of a beginner kit. You could solder it together. It sort of ran a Wi-Fi hacking tool. That's kind of cool, but it wasn't our project. It was a general purpose beginner hardware developer platform. It had like breakout pins on the back that you could connect sensors to if you wanted to. And it was a beginner programming tool. So it was an all-in-one. It was your one-stop shop for doing whatever the hell you want, provided you actually knew how to use the tool. So that was the first big fallacy of this design. Before we actually gave up designing the other boards, you can see we went through a little evolution process here. I wish I had bigger pictures of these, but we ended up designing some other crappy prototypes of the Hackcat and the Longcat that didn't exactly pan out. Oh yeah, and then down here is the evolution process of the Nugget, which the circuit board hasn't changed much, but the enclosure has a little bit. It's become more of like a Game Boy type thing. Okay, so this brings me on to the next key thing that we learned, which was that if you're trying to sell a product, you really need a big unifying idea. So this wasn't something that we realized for a while, but basically the point that I'm trying to drive here is obviously creating a multi-tool sucks, because if you can't really explain in a single line, maybe 1 or 2 sentences what this product does, and if you barely understand what it does yourself, you're going to have a hard time explaining or selling this to someone or explaining to them why the hell they would actually want to use this tool. This slide is poorly made, but I'll elucidate in a second. So one common mistake that I think a lot of designers get wrong, and actually where we went wrong, is that a lot of them essentially try to do what I call is just reinventing the Arduino. So what I think Arduino got right with their platform is their target audience is developers. If you're trying to sell a product, your target audience isn't developers. You're creating something that's supposed to have a single purpose use for the person that you're trying to sell to, and you should really know who these target people are. So I think Arduino got that right in that their target audience is basically developers and people that are trying to develop products. But I think if you're doing what's basically recreating your own kind of multi-tool, you're basically acting as a shitty proxy for devices that already exist out there. There are some exceptions to that. For example, Adafruit. I'll talk about this more at the end, but what I think Adafruit got right is they identified the need for, well, basically what they did was they also created their own versions of these multi-tool hardware platforms, but they repackaged it in different form factors, and that's where they have a one-up over something like Arduino. You can see they have, I think this is called like the LilyPad or something. It's supposed to be extra beginner-friendly. Instead of breadboard wires, you can clip on alligator clips. You can plug in a battery, so it's portable. They have the Trinket, which is like a really tiny version that you can use if you're not doing a whole lot of hardware stuff. And then you have the Feather, which is also battery powered. It has like a ton of expansion modules, kind of like the D1 Mini. But I think Adafruit is one exception to this case that got this right. So I'm actually going to go ahead and skip through some of these since I'm coming short on time. But somewhere around the 2nd or 3rd month of our development process, we decided to do something bold. So we didn't exactly have a product that we could just market and sell as like a finished thing, but we did something kind of crazy where we decided to just advertise it on Hack5 through the videos that we were creating and see if anybody wanted to buy this. So we were kind of working backwards. We were just experimenting to see what kind of people wanted to buy this design, what they were most interested in. So the very first video that I did was how to use the Nugget in order to detect Wi-Fi attacks. Damn, I wish I had a video. But basically the demonstration that I did was I had one Nugget that was set up to do Wi-Fi sniffing and another one that was running deauthentication attacks to kick clients off a Wi-Fi network. And I basically showed an interesting proof of concept that allowed beginners to visualize what the actual process of running one of these attacks looked like. So that really hit. People liked that demonstration, and they also liked that it was a really cute form factor. So we actually ended up selling out of our entire stock within, I would say, the first 2 or 3 weeks of this video going out. So that's when I decided that I wanted to focus more on these beginner Wi-Fi hacking demos, since people really seem to connect with that, and since most of our target audience that was watching these videos were beginners. At this point, though, we still wanted to try to appeal to everybody, so this was still a general purpose multi-tool for hacking, for programming, and hardware expansion. So my friend Cody decided to start experimenting with MicroPython, which is a programming language that runs on the Nugget. So this is where things got a little bit confusing, but after selling out of our initial stock, we decided to see how long we could just run this thing out. Let's produce another round of these boards, order more components, see how long we could ride this project out, and continue selling it to people. Still really with no clear idea of what our product actually did, except that people thought it was kind of cute, which was actually kind of disappointing because lots of people would just buy our product thinking, hey, it's cat-shaped, that's kind of cool. But then they got kind of pissed when they realized it didn't actually like do a whole lot at this point. So we basically were just experimenting with this design, creating random videos every so often. I was creating Wi-Fi hacking videos. My friend was doing programming videos. And then I think sometime around October or so of that year, we flew to Los Angeles and we hosted our very first workshop featuring the Nugget, just randomly. So this was quite a mess. Since we still wanted to appeal to everybody, we advertised this workshop as the general workshop to learn programming with Python, soldering, and also Wi-Fi hacking. So I was in charge of teaching soldering, and then right after I taught them how to hack Wi-Fi, and then right after my friend taught them how to program with MicroPython. So this was all a complete mess. People were really confused about this product. And it was kind of honestly embarrassing. You can see though, so the workshop that we did in October, we decided to go with, we decided to create like Halloween edition nuggets. This is something that ended up actually sticking. And this is something I wish we committed to earlier on, but there's a point I'm going to get to later on in this presentation if I don't run out of time, which is telling a story through your product. So one of the ways to do that is by essentially creating like a character or an icon that people can associate with. In our case, the cat theme really hit with people, and I really wish we leaned into gamifying that more towards the beginning. But that wasn't something we realized until the very end. But yeah, these are some really cute designs that we advertised and ended up selling a bunch of these products. So anyways, about 4 months into this project, we were getting some pretty consistent sales. People were buying our product via our web store, which is Redia, which we were advertising through our YouTube show. So we were getting some pretty consistent sales, also some pretty consistently confused customers, but I was creating more Wi-Fi hacking focused tutorials. So I was showing people how you could do stuff like detect when a particular phone or device enters a room with the Wi-Fi nugget. And I was also showing how you could do some other basic networking stuff like create a like how you could legally practice hacking by turning your nugget into a vulnerable access point. So that was all really cool, and people really liked this idea. My friend Cody was still focusing more on the programming aspect. Damn. My friend Cody was still focusing more on the My friend Cody was focusing more on the, damn it, it's like I'm going through puberty again. My friend Cody was focusing more on the programming aspect of things. And at the time, it just so happened that the developer of the D1 Mini platform that I talked about earlier came out with this new design called the S2 Mini. So this is where things became really confusing. So my friend Cody started experimenting more with this S2 Mini since it was based around a hot new microcontroller that could do a bunch more cool things. It had more pins, it was dual core, it was faster, and it also had a really hot feature called native USB, which could basically be used to run USB attacks and some of that other cool stuff, which I'll talk about more in a second. But most importantly, it supported a language called CircuitPython, which in my opinion is better than MicroPython. It's easier to get started with. So my friend started focusing more on the programming aspect while I started focusing more on Wi-Fi hacking. So this is where we created sort of a dichotomy with this product, because now we were really confused about what our product actually did. We did something kind of stupid where instead of actually developing something new with this new hardware thing, we decided to just go ahead and start also selling this on our store alongside the old microcontroller. So now we had a split of products where we were selling a Wi-Fi nugget that was called the D1 nugget with the old microcontroller and the new one, which was called the S2. So this is all really confusing because as an average person coming to our store and seeing these two very arbitrary nebulous things, how the hell do you know which one to pick? And more importantly, more people were interested in the Wi-Fi hacking aspect, which the S2 didn't support. So we got a lot of confusion where people ended up buying the wrong product. They got pissed at us. We got a lot of customer support emails, and that was a real big nightmare. So around the 4th or 5th month, this is when we really decided that we needed to figure out what the hell to do with our product. So we had some pretty good sales at this point. I think we were selling somewhere in the hundreds, which was pretty good because we only put out maybe 4 or 5 videos. And basically the return of investment on that was pretty good for how little effort we were putting into marketing these things. So at this point, the prospect of actually working with the cybersecurity vendor Hack5 came up, where they said, hey, maybe if you want to start selling this through our store and you come up with a cool use case for it, then maybe we could collaborate on something. Problem is, people were already confused enough about what the hell this product was supposed to do. So we would have a hard time selling this to the Hack5 customer base. So at that point, we realized that we really needed to come up with our own big idea and something that we could actually sell this product as. But since we were also confused about what the hell our actual product did, we decided to really double down on the idea that the Nugget was truly a multi-tool for everybody, and that we were the only ones that got this idea right. It supports 2 different hardware platforms. You can program on it. You can do Wi-Fi hacking, basically everything. Terrible idea, though. So what we ended up coming up with was that we needed to come up with our own customized software. So what was initially lazy about what we tried to do, and also is a mistake that I think I've seen, I'm not going to call out any specific projects, even though I have a few in mind. But one of the biggest mistakes that we made was we essentially designed this product and we said, well, since this is a multi-tool, we're just going to dump this into hands of people and we're going to let them figure out what to do with this product. Terrible mistake. And that's also a mistake that I see lots of other makers sort of kind of doing. I'll talk more about that at the end, actually. But basically, we were just relying on the fact that there were other community projects out there, like the dauthor, like CircuitPython and Arduino, and we said, hey, we're going to give this to the users. They're going to figure out how to use it themselves. That didn't end up panning out so well, so we decided to create our own customized software for it called the Invader. So this one was kind of a spin-off of the dauthor project. Not entirely, but we wanted to pack more features into this and make it into a Wi-Fi hacking suite. So you could use this thing to learn about network defense. You could detect if there's a threat on your system by creating a honeypot with this. You could also use it to detect deauthentication attacks, disassociation, beacon floods, that kind of thing. It was supposed to be a general tool for learning about Wi-Fi hacking and basically everything. You can sort of see where this was going. This also became a mess quickly because my friend just kept suggesting like more features to add to the product without me ever actually finishing any of the like initial suggested ones. So this also sort of started to become a general purpose like multi-tool for hacking, and that was kind of a really big mess. I'm actually going to skip this because we're low on time, but this was a, whoa, shut up. Okay. So that was supposed to be a demonstration of the Nugget Invader, but I'll save that for maybe another talk. So at this point, we were still selling the D1 Nugget, the S2 Nugget. People were really confused about these very abstract naming conventions. But we decided, hey, we finally have a direction for the D1 Nugget, which is the one that supports Wi-Fi attacks. It's going to run this product called the Invader, or this software thing called the Invader. And that's what we're going to start selling it with. As for the S2 Nugget, it was kind of lame. We decided to sell it with CircuitPython on our store. And inevitably, people just bought this product and they were like, what the hell? It doesn't really do anything. But yeah, that's where we were at this point. So I think this brings me to my last point, which is about picking a niche, and then I'll wrap up real quick. But sort of in the ideation process, or I guess like the creation process of this design, since we initially started out, as I said, just wanting to get rid of all these components, and we didn't really view ourselves as actually developing a product, we worked backwards to learn a lot of these pain points that we now realize today. And one of the very first, one of the most important things that I think any product designer should take into consideration when creating something, besides knowing your target skill level, which I talked about earlier, you should also know really who it is you're selling to specifically. That's not something we really knew. We were trying to appeal to programmers and hackers and hardware developers and everybody. But we eventually narrowed that down by just putting our product out there and figuring out who was buying it, and then eventually honing in on that. So anyways, sometime around the 5th month, we were in a rush to produce the D1 Nuggets. We were going to sell it with the Invader project on Hack5, since that seemed really promising. I would say we were somewhere around like 600 or 7 modules that we sold on our personal store with really poor advertisement. But our partner, Darren, who runs Hack5, promised that we would make numbers way above that if we started selling with him. So we started batch processing all of these nuggets. In like 2 days, I managed to assemble, I think like 150 to 200 by hand. And then I spent the course of a month really going ham on developing this Invader project and making it all spec'd out so we could sell it as a finalized thing on the Hack5 store. And in the meantime, while my friend Cody was waiting for me to finish developing that, he started working on more CircuitPython proof of concepts. So this is where shit really hit the fan. So, oh, also this is So I don't know if any of you guys noticed, but we were developing like through-hole modules, but we eventually pivoted towards like an SMD design somewhere in the middle of this. It's a bunch of nuance. I'll actually skip that. Okay, but anyways, somewhere around the 5th or 6th month, when we were set to launch this product on Hack5, my friend Cody discovered that the S2 Nugget that he'd been experimenting with could run something really novel. It could do USB attacks, which was really cool. So if you guys aren't familiar with HID attacks, which is human interface device attacks, this is essentially where a device like the Nugget emulates a keyboard, and when it's plugged into a computer, the computer is going to inherently trust this since it thinks it's just a regular keyboard that's been plugged in. However, it can be pre-programmed to run like a bunch of keystrokes super fast and type them out into a victim computer, such as this demonstration that I'm doing here. So we found out that the S2 Nugget had that capability. My friend was like, hey, this seems a lot more clear-cut. What if we focus on developing the USB attack capability of the S2 platform and sell this to Hack5 instead? It should be a simple proof of concept. It's more in line with their tool since they also have USB attack products. And it's a lot less convoluted than this dumb Invader project that we started working on. That's also another point that I want to bring up kind of disconnected is if you're developing a multi-tool, everything is a feature, so it's hard to focus in on which things need to be improved or added upon since there's too much shit to focus on. So anyways, we decided to make this crazy pivot at the last moment, and I spent another month or so just going hardcore, focusing on developing this attack platform instead, which we ended up calling the Rubber Nugget. And then I ended up also focusing or completely switching over to this new platform. So if you guys are confused about the name, the Rubber Nugget is basically a portmanteau of the USB Rubber Ducky and our Nugget project. So that's the Hack5 product that does keystroke injection. It looks like a normal USB, but when you plug it into someone's computer, it starts typing out a bunch of crap and it hacks them. So at this point, we were kind of having a branding/identity crisis. People were really confused about our product. They didn't know where to buy them since we were selling on our store. It was called the Nugget Invader. We had the Rubber Nugget. We had all sorts of crazy crap going on. So we really needed to basically figure that all out. So we ended up going with the name Rubber Nugget. So after I finished developing the USB attack software, we decided to do the soft launch on Hack5. Over the course of 2 weeks, we hand assembled over 300 of these devices. Another key thing is you can see we also, here we go. You can see we also made a little design improvement where we put an enclosed faceplate over it and like a little button so it felt more comfortable than the exposed circuit boards that you might have seen in the previous slides. But yeah, anyways, this was really crazy. This was a hard pivot for us. And of course, lots of our personal customers were a little let down that we stopped developing the Invader. They were still confused as hell because the D1 and the S2 were floating out there. They still didn't understand that naming convention. But then all of a sudden, out of nowhere, this new character appears on the Hack5 store called the Rubber Nugget. Turns out we sold out all 300 of these modules on the very first day. People thought this was really cool. And we ended up turning it into something that was a little bit of a more complete and polished product at this point. We had our own packaging that I designed. We had our own little insert cards with a QR code on the back, I think. I had my own sticker that I included. But basically, this was a USB attack suite for beginners. And basically what this offered over some of the other Hack5 tools was it was a cute gamified version of some of the existing hacking tools that made it really easy for some of the more beginner audience in their cybersecurity customer base to get started with this kind of thing. Because it's a lot less intimidating than like the Rubber Ducky that I showed you earlier. Okay, so I'm going to go ahead and wrap up by telling you guys basically where we are today. I did not update any of these slides. Cool, but basically some key takeaways that I think are really important. Having cohesive branding, I feel like. I wonder if I have a slide on that. Having cohesive branding and being able to tell a story with your product allows the customer to really connect to it. I think what I'm trying to say with that one is if you yourself don't understand the product or you don't understand who you're selling to, then customers or people that come to this product, they're not going to really understand if it's for them, they're not going to know if it's right for them, and they won't want to pick up this thing. I also think having more on that idea of telling a story with your product, I think it's also important to have, I guess I would call it like one thing that we leaned heavily into and that we're starting to focus on more is more of like the graphics and the branding and that kind of thing. And we're actually allocating like more of a budget to graphic design. But one thing that people really connected with our product is the fact that, of course, it was cat themed, it was really gamified and that kind of thing. I think that aspect is particularly useful. Like when you look at some other companies out there, like maybe GitHub, for example, with their Octocat. I think that's really cute. People connect with that, that kind of thing. That's something that I think is really important to be leaned into. Besides that, I think also the community aspect of this is really important. If you are designing a general multi-tool for everyone and trying to leech off existing things that are out there, kind of like we did at the beginning, which was creating a platform saying, you know, you can use Arduino, CircuitPython, all these beginner, all these community stuff that's already out there. I think that's a terrible idea, and it's going to be hard to build a community around your product that will want to reciprocate and also develop stuff for you. So also another key thing about this design is all of it is open source. So anyone that wants to create any of our projects or inspect our hardware, it's completely open source, and that's also been a really big thing for us. I think, so I'm sort of going off on a tangent here because I had to prepare these last slides, but the last thing is, I think also generally, a thing that I personally learned from this is, well, actually, I would say that working with and targeting this towards like more of an open source community and like makers and hackers and that kind of thing, they've been generally more forgiving about our product and also have helped us along the development process with like this experimentation and that kind of thing. And also people have helped contribute to the actual like software and everything like that. So really giving people something that they can believe in and understand and giving it like a clear focus, I think is really important. So stuff that we learned, you should choose a niche. In the end, we learned that that was our beginner cybersecurity audience and not programmers, makers, hackers, developers. Oh, another thing that we learned is identifying who your competition is. I think that's one of the first steps if you're actually trying to create a product that you're bringing to market. Identify who your competition is, how you can achieve basically feature parity, basically how you can get to the steps where they are, identify who's above them, and then eventually work up towards that. So we worked backwards from there, where after all of these months, we're finally identifying who our target competition is, and we're sort of working on the next features to build from there. Tell a story, I just sort of talked about that one. Yeah, that's basically it. And now where we are today, we're still developing hardware. We're still trying to sort out this branding shit show. And we're currently about to hand assemble a whole batch of 500 modules for DEF CON. So actually, we just did our first experiment with outsourcing our assembly to China for the first time. Previous to this, we were just hiring random makers in the community. But we made a huge screw up that I think is a really important takeaway, where one of the modules, particularly the S2 module, we decided to go with a cheaper vendor on AliExpress without actually testing the design. But it turns out they forgot to connect a single capacitor to ground, which caused our design to take an arbitrary amount of time, anywhere from like 30 seconds to a minute to start up. But we have 500 of these modules that I now have to fully fix by hand over the course of the next 2 weeks. So if you guys are also designing hardware, just a random takeaway, make sure you test every little component before you actually slap that shit on a board. Anyways, that was my talk. If you guys have any questions, anything you would like to hear elucidated, let me know. Thank you guys so much for coming. This was a very last minute talk. I also want to give a shout out to SCaLE for letting me submit my talk actually last night and then approving it for the schedule today. But yeah, it was really cool to be able to share this story with you guys. Thank you guys for coming. If you want to learn more, you can follow me on Twitter at AlexLin to see what I'm up to. You can also follow our project on Twitter at HackHatTech. And if you guys want to pick up a nugget, I have some up here at the end. So thank you. Also, I'm glad I didn't piss myself. Hey.
Hey, so I think I said it was the rubber.
The rubber nugget, yeah.
That's the one that's the USB.
USB
used
type
to
platform.
injection.
Yeah, what's actually crappy. This one. Hello. What's actually kind of crappy is
Is everyone able to hear me? All right. I think we'll go ahead and get started, unless anybody knows anybody that's waiting to come into the room. Got some stragglers coming in. Welcome. So welcome. My name is Nathaniel Mccullum, and I am the CTO and co-founder of Profian. I'm also the co-founder of the Anarchs project, which you're going to hear about today. And the title of this talk is Confidential Computing: Why It Has to Be Open Source. Now, what are we actually talking about here when we're talking about confidential computing? Well, there are 3 different types of runtime isolation, and you're very familiar with 2 of them at least. The first is the standard virtualization model. And basically, we want to, with virtualization, we want to have isolation because it's really important, but what is it? So there's basically 3 properties of isolation. The first one is confidentiality. This means that people can't look in and see what your workload is doing. The second one is integrity, which means that people can't tamper with your workload while it's running. And the third one is availability, which means that your workload actually gets the resources that you are expecting to get. Now, generally, the last one, availability, is easily observed. So if your service is down, or if it's if it's not getting the CPU cycles you expect it to, and it's performing poorly, then you should be able to observe that pretty easily. The other 2, however, are much more difficult to observe. And there are 3 different modes in which we can talk about isolation. So type 1 is workload from workload isolation. So this is where, think of its typical cloud system where you have a host and you have multiple workloads running on the same host. And you want to make sure that one of the workloads can't reach into one of the other workloads and fiddle around with stuff. And again, we're trying to get those 3 properties: confidentiality, integrity, and availability. So the workload, one workload should not be able to, for example, hog all the CPU resources. Now, we can do this pretty well today, right? We have C groups. This is a solved problem. But confidentiality and integrity are a little bit trickier, and we're going to see why. That's because the second type of workload isolation, type 2, is host from workload isolation. And this is basically, we want to make sure that the workload cannot attack the host itself. And this should be pretty straightforward. You don't want workloads that are running on a system to be able to attack the host, because why? Well, then they'll be able to attack the other workloads. So it's really important to notice that with type 2 isolation, the entirety of our security model is predicated on type 2, right? So even though we want type 1, we actually have to have type 2 in order to be able to get it. Now, we can do this pretty well today. And Webassembly, for example, was designed, is a new technology with using new primitives to be able to provide type 1 and type 2 isolation. So you've probably heard a lot about WebAssembly outside the browser and how it's going to hit the cloud space. And that's because it provides a lot of great tools for being able to do these two types of isolation in a way that is very reliable, very lightweight, and so forth. However, we have a third type of isolation. And that third type of isolation is workload from host isolation. That is, what if the host becomes malicious and begins to attack the workloads? Well, there's really nothing that handles this today, at least not in our traditional cloud paradigms. So VMs don't handle this. A host can definitely reach in and tamper with whatever it wants to in a virtual machine. And containers don't handle this for exactly the same reasons. Type 3 isolation is very important for many types of workloads. If you have sensitive data, for example, this could be medical data. Just to give one example, it could be financial data. It could be regulatory data where you have to comply with laws, for example, the GDPR. However, there's also sensitive applications as well. That is where the application that you want to run may contain algorithms that are themselves a trade secret. And there's a number of places that do this. Lots of AI/ML, for example, comes to mind. And so we want to be able to protect both sensitive data and sensitive applications. But how do we do this protecting from the host? Now, the host could be vulnerable for a variety of reasons. It could be because the hosting provider that you are running on are themselves malicious, right? But that's probably not the most common case. The more common case would be something like a system administrator who goes rogue and decides that they want to cause as much damage as they can on the way out the door. Or it could be just simply that there is a kernel compromise. There's a number of kernel compromises, for example, that give you ring 0 access from outside of the server. And so these are really big problems. So the host can actually be malicious either based upon the fact that there's an entity on the other side that's malicious, or just simply due to a compromise. And privacy-enhancing technologies are top of mind for these types of situations where you want sensitive data and sensitive applications. These are things like homomorphic encryption, for example. But we'd like to introduce confidential computing. Now, hopefully many of you have heard about confidential computing. Confidential computing is the protection of data in use by performing computation in a hardware-based, trusted execution environment. And this definition was crafted by the Confidential Computing Consortium. The Confidential Computing Consortium is a Linux Foundation project, and it is based on open source software. So like other Linux Foundation projects, you can basically start an open source project there and can collaborate. And this is precisely what the Confidential Computing Consortium was set up to do. The CCC has broad industry adoption. There are players like Intel, AMD, ARM, Red Hat, Microsoft, Facebook, Accenture, Ant, and so forth. The list is quite long. In fact, that's not even the full list, not even by a long shot. So everybody wants to play in this space. Why? Well, you see, confidential computing uses trusted execution environments. And this is based on CPU hardware. So it allows you to actually craft a workload that runs in a way that is protected and encrypted by the hardware itself. So they encrypt workloads, and they protect integrity and confidentiality. And this is true even if, for example, you have a tap on the bus to the memory, right? You literally cannot observe and cannot tamper with the application, even if you have direct access to the hardware. So what's actually happening? Without a TEE, memory pages are unencrypted. So you have a typical workload, you've got some memory running, and everything is running in an unencrypted way. This is what we normally do every day. But with the TEE, the memory pages of that workload are actually encrypted. And they're encrypted by the CPU itself. So there's new hardware in the latest generations of chips. This would be Ice Lake Xeon from Intel and the Milan generation from AMD. And they actually have integration with the memory controller, and there's built-in circuitry for doing the encryption. And so basically, when when it comes time to set up one of these execution environments, basically you tell the firmware, I would like one of these environments, please. And it generates a new cryptographic key that's used for all of the memory associated with that workload. And then all of the memory is encrypted transparently using that key. The only way that you can get memory into the initial state is to ask the firmware to put it in, which the firmware does a cryptographic measurement of. And so now we know exactly what the contents of that trusted execution environment are. And then finally, you can begin execution by asking the firmware to essentially jump into that TEE for you. And it's really important that each TEE instance has a separate cryptographic key, right? So even if you were able to tamper one of those keys, it doesn't necessarily impact all of the other workloads that are running on the system. And it's also important to note that this is happening as a hardware primitive. So this is not something root has access to. If you have a kernel compromise and you are on ring 0, you do not have any access to this memory. So the memory pages are only ever unencrypted within the CPU. So as soon as you do a load or a store instruction, the CPU is telling the memory controller transparently to do that encryption back and forth. Once the memory comes into the CPU and is stored in the registers, it will only be allowed to use in those registers when you're executing in the context of the TEE, and then it clears the state of the CPU when it swaps out of the TEE for other applications. And there are two broad categories of TEEs. So we basically have implementations from all of the major hardware vendors. On the left-hand side, we have process-based TEEs. And the way that process-based TEEs work is that you have a normal Linux user space process, and when you set up the TEE, it is a sub-region of that memory. So you don't actually get a different set of page tables to manage. It's all just the normal user application, but a certain region of that memory is encrypted. There's two primary examples of this technology. The first one is Intel SGX. This is one of the older ones. Trust Zone from ARM came earlier, but we do not believe it meets the definition of a TEE, which is why it's not on here. But Intel SGX is about 8 years old, but really just saw limited adoption in different places until they brought it now. It's now available on every Ice Lake Xeon server as of this year. The other one, other major one in the process-based TEEs is RISC-V Sanctum. So for those of you who are interested in the RISC-V community, there is a design for Sanctum, which provides process-based TEEs. There's also another one which is actually not on this slide because it's not been released yet, which is ARM is releasing, you see Realms on the right-hand side. They are also going to be releasing a process-based TEE on ARM in the coming months. On the right-hand side, we have virtual machine-based TEEs. And the way that these work is different than the process-based TEEs. So in this case, you bring up a virtual machine, and then everything that's in the virtual machine is encrypted. So every time you cross across the virtual machine boundary in or out, you're crossing into the TEE at that point. And there are several examples of this technology as well. AMD SEV, Intel TDX. TDX has been announced, but it is not yet available in Silicon. But they are working on patches for the Linux kernel. You can go Google that for more information. SEV has had 3 generations now. The first one came out on the Naples series processors. They improved it again in the Rome generation. But really where it starts to get really fundamentally interesting is in the latest generation, the Milan generation, because that's when they finally added integrity support for memory pages as well. So that's the first one that now fully meets the criteria of the Confidential Computing Consortium. A couple other worth mentioning here. I've already talked about Realms. PEF is from Power, so IBM is working on this as well. But let's back up here and take a look at the larger picture. What are we actually trying to accomplish? We're going to talk about what Anarchs is in a moment, but I want to first start off by just giving our Anarchs foundational principles. There's 10 principles that we have in the Anarchs project. The first one is that we want a minimal trusted computing base. So in other words, there should be as little code as possible in order to get an application up and running And this is just simply for attack surface. The smaller the trusted computing base is, the harder it is to attack. Second is the minimum number of trust relationships. So who do you have to actually trust in order to get all of these pieces up and working? And we want to be able to minimize those as few as possible. Number 3, deployment time portability. It's really important that once we have TEEs, that we be able to do what I call functional equivalence of workloads. And that is when you're doing cryptographic measurements now of these TEEs to be able to guarantee what's actually inside them, you need to be able to determine, is this workload the same as another workload? Well, if you've compiled a native application, for example, on every single TEE, they're all going to have wildly different measurements. And so now you'll have to build a huge management framework on top to track which measurements are which applications. And it's very, very unwieldy. And we want something that's simpler than that. So think about, for example, a blockchain use case, where you wanted to be able to execute a job, and you wanted to be able to certify that this job ran in a TEE through an attestation report. And then you wanted to put the results of that attestation report on a blockchain for everyone, for time immemorial, to be able to validate. Well, we want this to be simple and self-contained, and so we need some kind of deployment time portability in order to be able to determine that this is, in fact, this workload, no matter whether it ran on Intel or AMD or ARM, et cetera. There's another factor of deployment time portability as well, which is that vulnerabilities happen. And they happen in hardware. And in fact, every single TEE I've mentioned has been compromised. Now, we shouldn't be fatalistic about this. The situation is, in fact, rapidly improving. Attackers are really having to put a lot of work in order to be able to actually penetrate these. But what happens if you have a hardware vulnerability today, and your application is running, and it has all of the stuff that keeps your business running inside of that TEE? Well, you've now just essentially lost all of that security that you've had because you've consolidated your trust onto a particular hardware vendor. So what we want is we want the ability to deploy a workload to another host, to another piece of hardware, without having to recertify, without having to do any sort of additional testing. It should be just an instant switch if you're running on one piece of hardware to running on a different piece of hardware when it becomes vulnerable. Principle number 4 is the network stack outside the TCB. And this comes from years of experience looking at kernel vulnerabilities. And in fact, all of the worst kernel vulnerabilities were all in the network stack. And so what we want is we want for the network stack to actually be outside of the TEE. And the reason for this is because if there's a vulnerability in the network stack, that's going to be really, really bad. And then we don't want that to be inside the TEE, we want it to be outside. Number 5, security at rest, in transit, and in use. That's pretty straightforward. We want to enforce that we always have encryption on everything, whether it's on the disk, whether it's on the network, or whether it's being used. It's an entire envelope, and once data encode enters the system, it never leaves unencrypted. Number 6, auditability. Pretty straightforward. That goes with the minimal trusted computing base as well. We want it to be small so it can be audited. We want it to be 7, open source, so that it can be audited, right? Many eyes make it much easier to find bugs. 8, we have an emphasis on open standards. On memory safety, number 9, and we have a commitment to no backdoors, and we make that as a public commitment to everyone who might use the project. So what is Anarchs? Anarchs takes Webassembly. It allows you to take an application written in whatever language you want to compile it to Webassembly, and you can deploy it using Anarchs onto any of these hardware platforms. So why Webassembly? Well, importantly, it gives us a bunch of these properties that we really care about. So it gives us that minimal trusted computing base. It has a minimum number of trust relationships. We have deployment time portability. We have auditability because we can actually see what is actually happening. We know that WebAssembly is well defined. And we also have open source and open standards. The same thing with Rust. Anarchs is written in Rust. And Rust gives us auditability because it's pretty easy to look through Rust code and make sure it's doing the right thing. It's much harder with C and C++, for example. It's also open source. All the code we do is open source, and as well as our compiler, right? So we're open source all the way down. And Rust also provides us memory safety, which is a really critical aspect of the system, because memory safety, if you don't have memory safety, then it's going to be a source of bugs for you, and we don't want those kind of security bugs inside the TEE. So why open source? Well, with open source, again, we get this minimal trusted computing base. We get to use the best libraries that are out there, that are well reviewed and well understood, and we don't have to write everything from the ground up. We also can make sure that what we're doing is small and tight, and anyone can audit that, which is the next point. It's also, we obviously want to be open source. We want to have open standards and no backdoors. So if you look at a traditional virtualization stack, let's talk about who you actually trust. So if you want to deploy an application in the cloud, these are basically all the different parts you have to deploy. You have a CPU and a management engine. Usually the cloud takes care of that. And then you have a BIOS and EFI, usually the hardware manufacturer in conjunction with the cloud. You have firmware for that, same thing. But notice that they're different colors, and that's because all of these components are coming from different places. And this is a lot of trust relationships that can go wrong. If you're deploying a common operating system, usually you'll have like your bootloader, kernel, and hypervisor, as well as user space and any middleware, from that sort of same provider. But if you're deploying an application just on bare metal, you still have to trust all that stuff. If you're doing a virtual machine, you get to trust a whole bunch more stuff. Because inside the virtual machine, we're going to reproduce all of the stuff that's on the outside, including the bootloader and the kernel, the user space, middleware, and multiple applications. And this doesn't really change if, for example, you're doing a trusted execution environment using virtual machines. And so when you actually have a TEE that's VM-based, what actually happens here is that we exclude all of the stuff that is outside of the virtual machine. Because now the virtual machine does not have an ability to tamper, or sorry, the host does not have the ability to tamper with that virtual machine. And so now we've just clawed back a huge amount of simplicity because we don't actually have to worry about vulnerabilities in all of that part of the stack. But we still have a lot of stuff that's inside the VM as well. Things like the BIOS, bootloader, kernel, user space, and middleware, etc. One of the things that's really important, by the way, and it's one of the reasons why Anarchs has chosen to deploy WebAssembly rather than a traditional guest virtual machine with a full operating system, is because the only way to maintain compatibility, and this is how you're seeing everyone implementing TEE VMs in the cloud, is that the host is providing the BIOS. And so the cloud provider provides the BIOS that sits inside of the TEE, and then you do everything else. But I thought the whole point was to exclude the host from that relationship altogether, right? And so we have in order to maintain this sort of compatibility with existing stuff, we end up compromising the integrity of the system. So what we actually really want is we want to minimize that and reduce all of those layers and just have a single TEE runtime where we can run our application inside. And so fundamentally what we end up here with is 3 components that you need to trust. And this goes back to that question of how can we have the minimum number of trust relationships? So the first thing that you have to trust in a TEE system that's well designed is you trust the CPU manufacturer. Well, I hate to break it to you, if you don't trust your CPU, you probably shouldn't be doing computing. Yeah, that's all I'm going to say about that. There's really no way you can have any guarantee about the output of any sufficiently large program if you really don't trust your CPU manufacturer. So besides the CPU manufacturer, who else do you have to trust? Well, you need to be able to trust that TEE runtime, so the bit that's sitting below your application inside of the TEE. And this is precisely what Anarchs provides. Anarchs provides a common, open source TEE runtime that is something that can be audited, tested, because it's open source, and it gives you that minimal relationship. So CPU, Anarchs, and your own application. Now, I hope you can trust your own application. Maybe there's reasons not to trust your own application, but I suspect that most of us have a pretty good trust in the code that we're actually writing. But there's actually some more that you need to trust. Because what good is actually bringing up a TEE inside of a cloud if you can't have any proof that it's actually a TEE, right? If you tell me, please launch my program, and let's bring it up in the cloud, and I'm the cloud provider, and I say, oh yeah, I definitely set this up. It's like super secure, the best. It's the best of securities. What kind of security do you have? Oh, it's all of them? All of the ones that you like? Yeah? All the securities. Yeah, you've got them all, right? Well, this is a bit like asking a kid to grade their own homework. So what we actually need to do is we actually need to be able to get some sort of non-forgeable message out of the application to prove that what is actually running inside of the application is, in fact, tamper resistant. And this is where an attestation service comes into play. Now, again, the way that the cloud providers today are building attestation services, besides the fact that they bring up a virtual machine with their own BIOS on the inside of it, inside of the TEE, they're also then running the attestation service in their own cloud. And they are managing, in the case of, I won't say any names here, but they're actually managing the list of the CPUs that are good within their own cloud. So this is kind of a problem. And so you need to be able to trust your attestation service. And the way that attestation works is basically, if you remember earlier in the talk, the firmware brings up the environment, and the only way to get pages in it is through the firmware. Well, this is where we get a cryptographic measurement of everything that's put inside of that TEE. And the attestation is a cryptographically signed message from the firmware out indicating the state of that particular application. And the attestation service is something that's running either in your own infrastructure or hopefully inside a TEE, but not in a way that you can tamper with it. And the attestation service actually checks the signature on that message to confirm that everything is correct. Now, because this is the modern internet and we do things in a modern way, you're probably also going to have an application registry that you're deploying applications from. And this definitely also needs to be in your trust model, although there's ways we can minimize that trust by using, for example, append-only logs and signatures. There'll be some interesting news in the coming months from the Bytecode Alliance, which is the Webassembly consortium, regarding this, but I will not steal their thunder. So this is essentially the components you need to trust. Right? Besides the CPU and your own application, there are three things that you need to trust: the TEE runtime, the attestation service that validates that the application is actually running in a way that's tamper resistant, and the application repository that's going to deploy your actual application into it. This is what needs to be open source. Notice the three pillars are all there, right? If you can't have confidence about these three important pillars, the application repository, the attestation service, and the TEE runtime, then you cannot have confidence in the system, because all three of these are required in order to have an efficient system at work. So we're gonna give a little demo here. Now I will ask that I'm gonna invite all of you to come to try.anarchs.dev, just not now. I know you want to do it. Hold on. Yeah, if we are going to be giving a demo, and I just don't want to swamp it with traffic while we're doing this demo. So I would like for someone to tell me which platform they would like to demonstrate. Intel? I heard an Intel. Oh, we got both of them. Let's put it to a vote. Okay, who wants to see Intel first? Okay, who wants to see AMD first? Oh, that's really close. You know what? It's really close because that's exactly the point. You need to be able to move your workloads from one to the other without any friction whatsoever. So I'm gonna do the smart thing, and I'm gonna click the Start Now button, which randomly picks one, because counting y'all's hands is just way too much work. Okay, so we're gonna log in again because we are allowing people to run random workloads here, and I'm gonna walk you through an application. This is a very simple Echo server. Now, the thing that's nifty about this is, I'm going to toot my own horn a little bit. We had at Profi, and one of our engineers, Richard Zach, just landed in the last few weeks WebAssembly support into Tokyo and Rust. And so you're seeing the newest stuff hot off the presses. But this is exactly the experience we want. We want it to just work out of the box with your existing language without having to do anything special. No extra tools, no modifying your application. We want you to be able to use the existing tool, frameworks that you trust. So we're using Tokyo, which is an asynchronous framework for Rust. And really, the only bit of code here that's specific to running in Anarchs is that line. And the reason for this is because we're going to be pulling in from outside a pre-opened TCP listening socket. So it's already opened. That's the only thing that's WebAssembly specific. Everything else here is just standard Tokyo. And so what we're going to do is we're going to set the socket to non-blocking. We're going to create the final listener, and then we're just going to start our loop. And we're going to listen for incoming connections. When a connection comes in, we're going to spawn a background task. Now this is async. This is not threaded yet, but this is asynchronous. So we're going to spawn an asynchronous background task to handle each incoming connection. And we're going to come down here. We're going to read bytes off of that socket. We're going to handle when the socket disconnects. And then we're going to write the output from that to standard output and back on the socket. Right? Pretty straightforward application, standard Echo server. And so let me show you how to compile it for WebAssembly. Normally, if you're doing Rust, you would do a cargo build. If you want to do it for WebAssembly, you add target equals WASM32 WASI. Yes, I can embiggen it all day long. My mom taught me how to do this. So yeah, normally you would run just a cargo build, but we could run a cargo build. We're just specifying a different CPU target. WebAssembly is just a virtual CPU for those that don't know, and WebAssembly is deployed in browsers, all browsers today, for many years. So it's a well-recognized, mature technology. There is a WASM64 in development. So the standard is basically done, but there has not been a huge amount of demand for it, interestingly enough. There are some, well, so there hasn't been huge demand in relation to the amount of effort that it's going to take to implement it. That's the way I should put it. Because we get a bunch of sandboxing stuff for free when you can have 32-bit pointers on a 64-bit system. And so there's a whole bunch more work to implement it. But people are working on this. Yeah, it'll be available. So yeah, so WASM32 WASI. And we have an application now that's it. So if we look in directory here, you see this Tokyo-echo.wasm. And that's our application. That's all we've done. So we want this to be an exactly out-of-the-box experience. And we have to have a little bit more. And the reason for this is that when you're running an application in Anarchs, you can't take things like environment and arguments from the host platform because the host is not trusted in this model, right? So you have to be able to grab those from somewhere else. So we have a configuration file called anarchs.toml, and I'm just going to paste this in here. And this is pretty straightforward. We're just defining that we want standard in, standard out, and standard error, as well as we want to open that additional listening socket. Now, if you remember back here, I said that this line of code right here is the only thing that's WebAssembly specific. Well, this is because we are pre-opening this file descriptor number 3. And this is right here where we've created that file descriptor number 3. So that's the only thing that's really specific to this environment. And so now we're going to pick our WASM file. And we're going to click deploy. I'm sorry? Oh, the file's pretty small. It's, well, that's the debug version. Let me do the release version. You're taking me off the path in my demo. This is where all the dragons lie. So I'm just adding the release flag. And this will just build the application with a bunch of additional optimizations, including optimizations for size. So what did I do? Yeah. So it's 2.1 meg, but that's everything, right? Think of it this way, the entire Anarchs runtime plus the application is still smaller than the bootloader and Linux in booting a VM, right? So just put that in perspective. Okay, so we have our application running here over on the left, unless it hasn't timed out yet. And we're going to, all right, it's connected. And so I'll say, and there it is. Yep. So now that's interesting, but let's run that same workload on a different technology. So we did Intel first. Now we're doing AMD. Notice there's no changes whatsoever to the application. And if you were deploying in this in Kubernetes, right, it's really just like a matter of picking a different target that you want for your application. So you can be up and running in a vulnerability in a matter of minutes. So we're going to do the same thing on SNP. I'm connected again. And this, whatever. You guys can see it now. You can see that this is actually a distinct system that's running. Now, I talked before about making sure that we could have an envelope where every time that data and code entered the system, it stayed in the system encrypted and never left unencrypted. So one of the problems that we have, I don't know if anybody saw the article recently that there's something like some crazy number of open security jobs in the world right now. And a big part of this is because although we've learned how to do DevOps at scale, for example, with GitHub and your cloud provider, right? We still haven't learned to do security at scale yet. And so everything is like picking and matching these like different tools that you have for issuing certificates and getting renewals and making sure the disk is encrypted. And you have to sort of glue it all together in a big Rube Goldberg machine. And it's very time consuming and it's very error prone. And if you're asking a junior guy to do it, you have no way in hell that it's ever going to be secure. So what we want is we want to be able to, we have people telling us all the time we should shift our security left. How many of you have heard shift security left, right? Okay. The problem is shifting security left doesn't actually work. And it just blames the developer for not being able to be perfect every single time. Is anybody perfect every single time in this room? I'm not. So I don't think that is, and blaming the developer doesn't really help us. We actually need to shift our security to the right. We need to be able to scale our security the same way we've learned to scale our developer experience and the same way we've been able to scale cloud deployments. And so let's see what it looks like to do an attestation. And we'll do it on SNP again since it's right here. And with our attestation, we're going to enable the steward. Steward is the attestation service. And we're going to change the protocol of our port from TCP to TLS. And we are going to run the same exact application again. So what's actually happening here now is that the workload has gone and done an attestation as part of the startup procedure. So it went out to that remote server, gave evidence through its attestation report to the server that this is a tamper-proof environment. The server has validated everything cryptographically to make sure that all of the measurements are known and so forth. And only once that's done does it issue a certificate for a private key which was generated, or for a certificate on a public key for which the corresponding private key was generated inside of the TEE. And so we can now do OpenSSL and connect to this. And you can see that we got exactly the same thing. Now notice what I didn't do. I didn't install a bunch of other additional tools, and I didn't have to worry about whether or not my key is going to be compromised or whether my disk was encrypted, because everything was encrypted always. And so there was nothing to mess up, right? All I had to do was change the configuration, and we were able to successfully shift the security to the right. Okay. So let's do another demo. This one's going to be a video demo just because I want to show a pretty complex attack, and that requires me to have root access on the server. So let me go back to here. And so we wanted to show that you can actually do something that's a little bit larger than just an echo server. So this is actually a multiplayer Wordle clone that we wrote. And basically, instead of trying to guess the word of the day, you're actually trying to guess the words that the other players have put into Crypto. And so as you type the words in, they show up. So I was typing in the word world. And there it is, and so forth. I'm going to skip ahead here. And so notice, purple, we got a match. That second player had successfully guessed the first player's word. And now this is important that unlike Wordle today, Wordle is generated, for those of you who know, the word is sent to the browser and everything is done server or client side. And so if you want to know what the word of the day is and you want to cheat, you can just do that trivially, right, with any browser debugging. But in this case, all of the words that are being guessed by the other players are now held on the server inside of an Anarchs keep. And because they are inside of this keep, everything is protected from the host. And so we want to see what it would look like if we wanted to cheat in this game. So we're going to put on our attacker hat. And we're going to run the Crypto application using WebAssembly, using Wasmtime. Wasmtime is not Anarchs. Now, please don't fret. I'm not picking on Wasmtime. Wasmtime is fantastic. In fact, it's our WebAssembly implementation as well inside of the keep. So this is not about dissing Wasmtime at all. But it is, however, about pointing out how easy it is with root access to be able to find secrets in an application. So we've launched it in Wasmtime, and we're now just going to grep the memory for words. So we found the process. And we're off to the races. So in a moment, what we're going to see here is we're going to see the words that the other, oh, there it is, young, is one of the other guesses that other players have made. And so all it takes is one root level vulnerability to have this level of access to all of your virtual machines, all of your containers, all of your applications running on a host in a traditional manner. That's a problem. And we need to be able to do something better. So we're going to show the same exact thing running again. By the way, we would get, if you were running Anarchs in debug mode, you could scan the memory like this too, right? When you turn off debug mode, there's no protections. So we're going to do the same thing again here. We're going to attack Crypto, but this time we're going to do it using Anarchs. And so we're actually doing an upload here. We're uploading the application to Drawbridge, and then we're going to, Drawbridge is the application repository. And we're going to deploy it right out of the application repository. That's that line, Anarchs deploy. It's actually way simpler than this today. This is an old video. Oh, I missed the good stuff. So we're going to do the same thing. We found the Anarchs application. And we're going to do exactly the same memory scan, just for the different process.
What do the error skip things mean?
It means that, I don't remember. It's a kernel, it's a Linux kernel thing, and I just don't remember exactly what case causes that. And that's it, we didn't find any words. So just simply by changing which host we were using, whether we were using Wasmtime or whether we were using Anarchs on supported hardware, we were able to defend the application from attack. Now, this is actually a call to action. I somehow lost my slideshow. There we go. We want to see your elite skills. So if you go to anarchs.dev/crypto, we will basically give you everything you need. You'll have the Anarchs application, have crypto, and we want you to hack it. And there will be cake, and by cake we mean hardware and cash. So please come give it your best attack. And the important thing here is that Profian is about to launch enterprise support for this, and we want to make sure that it's ready to go. So please come and do that. We will be announcing the winners of the first round at Black Hat, which is coming up here very shortly. And so yeah, you have a little bit of time to get your submission. And basically, if you can run crypto in Anarchs and you can successfully attack it from the host side, then yeah, you win. Last, let's do one more demo. So we actually didn't make this demo, and I think it's important to show this demo because I want to show that other people are making stuff too, and it can work in Anarchs out of the box. So this demo was actually put together by Microsoft. This was given at KubeCon. So we gave talks at KubeCon. There was a Webassembly day at the beginning of KubeCon, and basically everybody showed up and showed off all their Webassembly stuff. And so Microsoft basically touted what they've been working on for WebAssembly support in .NET. So they gave this application, and it's a little greenhouse monitor application. It's entirely written in C# using, I think, Blazor as their web framework. Yeah, this is, so let me pause the video here for a second, actually get back. Yeah, so this is the actual source code for the demo, and we forked it just so we would have a copy of it. And but we also set up a builder so that we could build all of this in GitHub Actions. And the reason we did this is so that this is completely reproducible. You can go and look at exactly how this was built. And we're going to run this on try.anarchs.dev. Now this is a little bit older version of the demo system, but we're gonna do exactly the same thing as we did before, which is we're going to choose that WASM file. And we're going to copy and paste our config. And now it's running. It is C#, so it's going to take a second to come up. Yep, there we go. And there it is. So that's C# running in WebAssembly on top of Anarchs. We did not write this demo. So I think it's important to show we're not the only magical people that can do this. You can do this too. So let me just give, in parting, a few last words. This is essentially what the Anarchs project is about. We have 3 open source projects. The main one is called Anarchs. That's the Anarchs binary. And that is what we use to create a keep. A keep is, in Castle terminology, we follow Castle idioms. And so a keep in Castle terminology is the strongest, most central secured place inside of a castle. And so that's the Anarchs binary creates keeps. We have 2 additional services, Steward and Drawbridge. Steward is the bit that does all of the attestations for you, all integrated into the system. And then Drawbridge is an application repository for being able to upload your application and then deploying it with just a single slug. Kind of Docker style, right? Like you're normally used to doing with Docker or Podman. And so basically what this allows us to do is we can unify these 2 different types of TEEs, and we can run the same application on both by using WebAssembly. WebAssembly has a standardized interface, or it's rather standardizing, it's in the process, called WASI. And WASI is starting off with things like arguments and environment variables and sockets, but there's actually other really interesting WASI APIs coming out, like WASI Crypto, which is a full-fledged cryptography API. There's a WASI NN, which is for doing all of your AI/ML stuff for neural networks. As well as many others. There's a bunch of people working on different APIs, and these are all standardized, right? When you're running on top of Anarchs, you're not developing to some custom platform. We want to give you a standard, out-of-the-box experience with standardized protocols and APIs. And so this is the bit that actually runs inside of the TEE, the WebAssembly engine, the WASI API, and then your application will oftentimes have a language binding. For example, if you're writing in C, you'll link against WASI libc rather than GNU libc or some other libc. And this is what gives you the ability to run C or C++ on WebAssembly. And all of that ends up in the keep. And again, the total package here is smaller than just your bootloader and your kernel on a Linux system. And this is really actually important for density reasons as well, because if you're running VMs, today we can share lots of pages. You know, if you've got 100 different VMs running on a system and they all have the same kernel, you don't have to deduplicate those pages. In fact, that's the way Firecracker works. You guys know Firecracker, the minimal VM engine. So they basically map the Linux kernel on the host side and then into the guest. And then those pages are all deduplicated across the host, which is how they get density. But in an encrypted environment, you can't do that. You can't share pages across multiple systems because each page is encrypted with a separate key. And so there's no sharing at all. We've got to be able to claw back that density by reducing the size of computation. And the end result is basically you just have this TEE, and all it is the minimum amount of stuff that you need to write and run your application, and everything else is up to you as the application developer. So please come check us out. Our website is anarchs.dev. You can try Anarchs at try.anarchs.dev, and which is what you saw today. Check out our blog and GitHub as well. Please star the project on GitHub. It's actually really important to us, so we'd like to know that you're out there and that you're interested. Please star and let us know. And we're a friendly group of people, so come chat with us on chat.anarchs.dev, and we would love to hear from you. Last but not least, I did mention that we are going to be releasing enterprise support for this. That will be TBD, but it's in the coming months. And we are calling this Profian Assure. So we will have, you can run it yourself, we'll provide support for it. You can run it using our services, and we will support you and give you resources there. Yeah, and that's basically where we are. What questions can I answer for you? Right now, the limit is, we got 4 gigs on WASI 32. So, but it's designed for microservices, right? I mean, this is precisely what we're trying to build is lots of smaller services rather than big monoliths. Yes, yeah. The Anarchs runtime itself. Just stick it in a container and make sure it has access to the device nodes. The biggest pain point will be that not all the kernel drivers are upstream yet. So the good news about Intel SGX, the last drivers that we need are currently staged for merge for the next release. So that will be coming very shortly. And AMD SEV-SMP is still a ways away yet. But if you're looking at running this in production, come talk with us. We'll provide you a kernel. We'll give you a stable experience. That's what we're here for. That is a great question. Say it nice and loud. No, they're not. No, they're not. It's actually a misnomer. So what actually happened was Intel modeled SGX after Trust Zone initially, and it was incredibly small. The initial limits were like 196 megs at the most, and many systems had BIOS configurations that were significantly lower than that. But what they did was they realized over time that the real market for this is in the cloud. And they were trying to do it first in mobile, and then we were trying to do it on laptops, and it just didn't get traction there. And so what they're doing now is they're pivoting it to the cloud. So what they have done is they've removed it, unfortunately, from the newer generations of the mobile devices. So it's not in your laptop anymore, which has led many people to think that SGX is going away, which is not true. SGX is continuing. Not only is it continuing, they brought it in the latest generation of the server chips, and also, what about their new technology, TDX? Isn't that going to replace SGX? It's actually not. The virtual machine technology is actually built on top of SGX, so both will be here for a while.
Yeah, the whole reason I thought it was going away is because my Blu-ray player software no longer works because SGX is missing.
Yep. Yeah, that's exactly the case. And basically, I won't pick on Intel. I like Intel, but no, I don't think the rollout of SGX was managed very well, and so you got a few sparse systems that had access to it. For example, there was some 7th gen Celerons, which they were and Atom, which they were targeting towards the mobile space, and then they had it again in the 10th generation. In like the i7 1065 and the i5 1035 CPUs, very good CPUs, by the way. But they brought it back for those. But then when they did the overhaul for the 11th generation, they dumped it. So it's no longer there on the client side, but it is there on the latest server chips. In fact, the latest server chips are the only server chips you can get it on. So you have to have Ice Lake Xeon. Yes. Yes. Yeah, exactly. So there's definitely a huge market for it in the edge space as well as in the cloud. One of the things that we are seeing is that the place where people are most interested in it today is they have data and applications that they can't put in the cloud because they can't disclose them, or they're regulated in some way, and so they can't. So if you're in the banking industry at all, right, FRTB is coming for you, whether you like it or not. Yeah. Oh, great question. So SEV, the 2nd generation, not the Milan generation, was available in the AMD EPYC embedded line. And I can't talk about future AMD products, but there's a lot of demand for it. So that would give it to you essentially in a mobile form factor. ARM is also planning on, ARM is not a manufacturer, right? So they're releasing the IP to manufacturers, and you will see this in a variety of form factors as well. We do absolutely intend to support ARM realms as soon as it's available. In fact, we support ARM today. You can actually run Anarchs without encryption on a Raspberry Pi. Yes? No, and in fact, the earlier generations were vulnerable to Spectre attacks. So side channels still remain a problem, and CPU vendors need to fix those problems. The good thing I would say is that everyone is paying attention to those problems these days, and they are getting worked on. But you should expect to see some more side channel vulnerabilities. And yeah, there are a good example of like attacks that are practical today on SEV. There's Plundervolt is one of the ones where you can basically trick the CPU into acting in different ways on different keys if you undervolt the CPU. So that there will be support for a defense against that in the next generation of chips. But you can see that like these attacks are getting harder. So you actually not only have to have physical access to the machine now, you actually have to be able to revolt it.
Wouldn't that get easier since a lot of that is now software controllable?
Yeah, in fact, some of them are software controllable, yes. Glad you liked it.
So I could run my workload view, I could run it on my own hardware.
Yes.
At what point will I be able to run it with, say, big cloud vendor X?
So there's a reason why this domain says snp.equinix.try.nanarchs.dev, because this is running on Equinix today. If you also go back to the main page, you'll see other platforms coming soon. That does include a large 3-letter cloud. So wait and see. Yes? With what is PKVM? I don't know. Yeah, correct. I believe that that's one of the dependencies for CCA Realms, which is coming out, which has already been announced. So yeah, basically you need that support first. Then you need the memory controller encryption support in actual silicon to be able to swap the keys out for the memory pages. And once you have those two things, then basically you have an API interface to the firmware at that point. Great. Yeah, the CCA Realm stuff is not yet out. There are, there's an emulator available, but the firmware interfaces aren't finalized yet. Well, I think we're at time. Thanks everybody for coming.
Hello? Ooh, yay. The good news is I will not be singing today. All right. Mic check again. All right, so it sounds like we're good. I think we're officially at 4:30 or so. Thumbs up. 15 seconds. All right, we'll start. I am going to do the podium thing because I've got notes, and Carlos, my friend, has shamed me that I did not prepare sufficiently to remember my notes. So I would like to occasionally glance at them and say, Mary, this is just like old times. Mary used to be one of my students. She always walked in late with a Starbucks. This is awesome. I'm having a flashback. All right, so good afternoon, everyone. Thank you so much for being here. We realize that you have a choice at SCaLE conference, and either there's a really good one after here or you want to get a seat for it. I don't know. So my name is John Siklick. I'm hoping my voice is going to last. As you can see, what the title is on my, it's about end of support operating systems. This paper was originally created as part of my SANS master's program. I'm a glutton for continued education as long as I work at a place that will pay for it. So SANS Technology Institute is the accredited university portion of SANS. I'm sure many of you have heard of SANS. So one class to go. I should be done in a few weeks, but that's how this paper came to be. And coincidentally, this paper was supposed to be finished when SCaLE was supposed to be held, where, March, right? March. And then this got delayed. I was late on my paper, so it all worked out. All right, so just a little about me. First, I figured I'd throw up my Weird Al and William Shatner pictures just to let you know I am one of you, right? We all embrace the same things. I heard a funny quote yesterday, you know, do you have 30 years of experience or 30 years of doing the same thing? So I thought that was kind of cool because I do have 30 years of varied experience over the years. Was in the Navy Reserves for 28 years. That's actually how I became got into cybersecurity. I met one day a young man who was a PhD working on something that he said was called Tor, and I didn't know what he was talking about, but I'm like, now I could say, hey, I met the guy who created Tor. And as I mentioned, I'm in graduate school, one more course. I have been, since 2013, an adjunct faculty member at both Coastline College, who has a booth if you haven't stopped by there yet, and Long Beach City College. And I recently accepted a full-time teaching position at Long Beach City. So starting this fall, I am a full-time professor, part-time Boeing. I'm excited about all that. So what are we going to talk about? Generally, open source operating systems and what happens when they reach end of life. And what I'm thinking about, what this might mean to you, is if you're working someplace where operating system open source are being used because the management's like, oh, it's free, yeah, we like that. But understanding that you've got to pay migration costs eventually, you've got to move on. And then if you don't, what are the impacts? What are the potential risks that you're putting on the network? And then if they really have to stay with an older operating system, educating them on what options are available for continuing to extend your maintenance. And then again, if we got some old stuff on the network, like a VAX machine in the back of someone's car, for those of you who were here earlier, what else can we wrap it around? My friend Carlos and I don't know if you were there back in the early days of where we worked, where there was a system that's like, no one touch it. We don't know what it does, but we need it, right? So we just had to wrap stuff around it to protect it. Quick show of hands, how many people are running Linux at their home? Been easier to say who's not running Linux at home. Okay, yeah, so I'm in good company, right? If you go to a different group of people and they're like, Linux, what's that? What are you talking about? Well, yeah, we are at SCaLE. Excellent point. That would be, it would be funny if people didn't do it. So what are the risks of unsupported operating systems? So I can't say I claimed a quote or created a quote, but I'd like it. Every day is a 0 day, right? There's always something new. And our typical hygiene for a vulnerability is, oh, get the latest patch. We can't do that with end-of-life operating systems because generally there are no patches. Also, if we have application software running on there and we want to update that either for vulnerabilities or functionality, typically we start getting hindered by that, right? The vendor will say it's not supported on that older operating system. You start having a little bit of a Frankenstein system that you have to manage. So what are all these costs that we're trying to balance? Migrating to a new operating system, and if you're running dozens or hundreds of systems, that's a real cost. Paying for extended maintenance, it's relatively cheap per unit, but then again, how many units you have to scale that out to? I mentioned finding other controls. There are a lot of notable examples of Windows going end of life. Please don't boo here, throw stuff at me because I said the W word. But it is an operating system that we all must learn to live with, right? It's still 70+% of the market. Interesting, I was teaching a cyber camp for high school students last week, and I went and brought up the metric real quick, how many desktop systems are Windows. And I remember bringing up that chart when I first started teaching, and Windows still had 90+%, and now it's in the 70s. So, it's shifted, but it's still extensive out there. So I was in the Navy, I mentioned that. The Navy's IT-21, which was Windows XP, Navy loved to put 21 in front of, in program names. IT-21 was using Windows XP, and they were nowhere near ready to migrate when the time came. So they were paying Microsoft hundreds of thousands of dollars. And for those of you who trust ATMs and are willing to use them, they are, a lot of them are Windows-based, and they typically get caught up when the next Windows iteration comes along. In fact, I was on a phone call just this week where they said the Navy issued a warn order, because we just can't say a notice, and about Windows 10 going end of life and having to move on to Windows 11. I'm like, okay, when will the insanity stop? So why did I pick Ubuntu? It was a great case study for me. One, I was using it at work. I don't talk really about what I'm doing at work because I didn't want to go through the whole process of getting that approved, but it's what inspired it. I think whether or not, okay, let's do that. So the whole room raised their hand when I said, who's running Linux at home? How many people are running Ubuntu at home? Okay, so we got a mix there. We could have a religious war over Ubuntu distros here, but it's still widely used. And there are two versions of Ubuntu under what is called ESM, Extended Security Maintenance. 1604 is the one that most recently went end of support. That's what I use at my work. And then 1404 a few years earlier in 2019 went into support. So we've got two great examples to look at and see how these systems are aging, both with their ESM support and systems that don't have that support. These slides will be, I will put these slides up on the SCaLE site, so you'll eventually have them for the links. Now, interestingly, I spoke with a person from Canonical on what I was trying to accomplish, and he had written a paper more of a sales point of view on 1404 and said, here's all the stuff we fixed under 1404. I'm taking a different approach of, here's what's broken in 1404, 1604, because I'm not trying to sell you anything. So how did I go about this? I tried to find open findings in both 1604 and 1404 that that had ESM, extended security maintenance, installed and receiving those updates, and one that basically is frozen in time, only has patches up until the software went into support. I used Census. I started off using Shodan because that was like always my go-to for Internet of Things, and one of my students helped me out and pointed me to Census, which honestly I'd never used before, and gave me much better results in identifying systems. Canonical, the makers of Ubuntu, were of little to no help. I guess I should have thought that out before I said that on recording. In telling me how many systems were out there using ESM, they pointed me to a graph that just basically didn't help at all. They just didn't really want to tell me how many people were buying it and how many systems they thought were out there. So basically, I was just going out and trying to find 1604 systems. A Canonical rep did help me come up with a keyword search, and it's in my paper that this is based on how to identify Ubuntu. It is not 100% accurate. Like you can't just go touch an Ubuntu system on the internet. It says, hey, I'm 1404. You had to look for certain versions of packages, and then from that discern whether or not it had ESM on it. So it's a little bit dicey. I could not perform vulnerability assessments on those systems out in the internet because they didn't belong to me, and we all know we don't do that. So, right, Mary, remember, don't scan a system that doesn't belong to you. You can scan your friend, you can scan your friend's nose, but you can't. So the three flavors I did. Baseline system, you go to the Canonical website, you pull down Ubuntu 1404, 1604, don't apply any updates, you just install it, that's it. Then I took those systems, cloned them, and did an update and downloaded all available updates to when the software reached end of support. And then it became frozen in time. And then Canonical allows you to license up to 3 systems for free with ESM. So I installed ESM on a 1604, 1404, and have kept those current. So I did scans back in February, and towards the end of this presentation, I'll show you scans that I did this morning. I like to say I did them this morning so you have most current data. Let's stick with that story. Also in my test environment, just using VirtualBox to manage the VMs. The vulnerability management tools I use, so there we've got 2 VM acronyms. Nessus Essentials, which is free and will allow you to scan up to 16 hosts, and that's free pretty much forever. And then a little bit apples and oranges, the Insight VM, again, the VM stands for Vulnerability Management, is a little upscale of a product. I only got a 30-day license, so it's more comparable to Nessus Professional, but I don't think at the time that Nessus was giving me a Nessus Professional license for any length of time. So I had to use a little bit slightly different tools, and you'll see that you get different types of results from these, or at least data to analyze. And then I did the vulnerability assessments on each of the VMs that I described in the previous slide. So between 1604, on the 1604, the 3 flavors, no updates, no ESM, and with ESM, which one's going to have the most vulnerabilities? The first one, okay. Yeah, this wasn't a trick question. I'm just trying to get audience participation here. So starting from the left, dark red is critical, high, medium, low, and then the blue are info, and those aren't really vulnerabilities. That's just details on the scan and the system. So as you can see, the baseline system is a hot mess with 21 critical. But so, just we don't really need to look at each number, but just this is like a good management chart, right? If any of you have ever needed to communicate to management, they like colors. Keep it simple. And honestly, right, if you're not a technical person, we could joke about it, but if you're not a technical person and someone is saying, hey, look, it's really bad and it's got a CVE number, and a 9.0, and they're like, oh, what are you talking about? But it's like red, bad. Oh, good, I understand. So we could see that as we get to the 1604 ESM, again, these are the results I originally did back in February, that the ESM system wasn't bad, right? You're always going to have a gap between your plugins being the most current and the vendor being able to provide the update. So that's not surprising at all. Also, if you, okay, another show of hands. How many people have used some type of vulnerability assessment tool in their work? Have had to do this? Oh, look at this, I'm preaching to the choir. So you can't trust these things right out of the box, right? You can't just turn this report over and go, oh, it's all red, we need money and all that, right? You've got to analyze these things. None of us would ever do that, right? We would not use fear, uncertainty, and doubt to sell our products. So Nessus uses a scale that they call the VPR, the Vulnerability Priority Rating. It's basically various math equations of how to determine the badness of a particular vulnerability. So I picked one of the criticals in here, and it happened to be a Samba finding. We're going to go dig into that in a little bit. But first, 1404 findings. So I've already quizzed you on between the baseline, no ESM. Between the 1604 and 1404, which system do you think is going to have the most vulnerabilities? Okay, so we're all over the map here. 9. Windows 10. So surprisingly, and we'll have a chart that will put these together. Surprisingly, the 1404 had less findings. It follows the same trend that the baseline is worse than the no ESM is worse than the ESM, but it didn't have as many findings. And I do have a little bit of a theory on that. If you're a Monty Python fan, the theory does not involve a brontosaurus, but I got some laughs on that one. And so we'll talk about that in a little bit. But again, 1404, same general trend between the three. Yeah, you see, Anne Elk and her theory on the brontosaurus, for those of you who know what the heck I'm talking about. So Nessus Essentials is very basic, like I showed you on the previous slide, right? These are just screenshots of essentially what it gave me. So Rapid 7, because I was using a higher scale product, gives you really nice visualization, right? So this would be the nice kind of thing that you would want to potentially use in management communication. And there's two particular ones I want to talk to, and I'm going to show you closer on the next slide. This one, so like to management go, well, that looks bad. Well, that's saying the percent of systems that are running obsolete operating systems. So interestingly, Nessus was able to determine that 2 of the systems had ESM and were getting security updates. It called it out. So that's good, right? So you don't have to deal with that finding and explain to an auditor. It's like, no, we're getting updates. Rapid 7 was not doing that. It was just saying they're all obsolete because they're, not the biggest problem, but an example of slight differences between the products. The other one I took some offense at, personally, and it's exploitable assets by skill level. So, okay, so this is for management, look, all obsolete, bad. Then we've got the one on, percent of exploitable by novice. Spoiler alert, I was not able to perform any of these exploits. So apparently whatever's below novice, knucklehead, is where I am. So who knows what goes behind these ratings, but I will let you know that I've had some of my pretty smart students help me out with this. Can you find something Metasploit? Like we have found data that says here are the exploits, there's information on that out there. I don't have enough savvy to actually work any of these exploits yet. I'm going to continue working on it because I would like to really be able to show. Because as you think about the things that we've shown so far, and even though we took a little dig at management, right? I guess I too late to ask if there's any managers in here. But well, probably not because everyone raised their hand that they were using Linux. But the okay, so I apologize if I offended any Linux using managers there. So the what was I going to do? What was I going to say, John? Oh yeah, so the exploits. You could see how we're building a story that you would want to demonstrate your management of. We're finding these systems. And if you're in anything that has compliance requirements, HIPAA, PCI, I can't, I'm sure we all could shout some other ones out. The use of current operating systems is going to be like the first entry. And if you're saying, well, look, we're still on something older, but we have extended security maintenance, at least you get a little off of their radar, depending on what their skills are. But yes, yes, sir.
Clarification, I would assert that an expert could do both the intermediate and the novice. The gradation there is kind of...
Oh, okay, so...
I'm an expert, but not
I get your point. Right. The expert cannot figure out the novice ones, right? Yeah. So it's a management chart. Yeah. And I didn't create it. This came from the tool, right? So yes, your point is well taken. I know. What was the Charlie Sheen movie? Okay, Carlos, are you counting how many movie references I make? The Charlie Sheen movie it wasn't Charlie Sheen. It was M. Night Shyamalan, where the aliens come down to the farm. Signs, right. They came all the way across the galaxy, they got on our planet, and they couldn't work a doorknob. It's like, how does this work? I don't know. Okay. Mary, please keep me honest on time, because I'm going to go into my stand-up routine pretty soon. So here's hopefully a good table for you. So this is the vulnerability findings from my first round back in February. Top table is 1604, bottom table is 1404, and then going left to right, baseline, update to the time it went into support, no ESM, and then updates with ESM. So this gives you another visualization of, again, there was one critical and 1604, two critical and 1404. So it gives you an idea of where they were. Again, the surprise being that like the baseline appeared to be better on 1404. My theory, going back to Miss Ann Elk for you Monty Python fans, is that how like antivirus definitions have to change, right? What's going on out there in the world? Plugins change as well that go into these tools. I suspect that maybe there aren't as many plugins in Nessus for 1404. And one of my supporting facts of that theorem is 1404 Nessus does not detect it has ESM, right? It flags it as an obsolete operating system. It only detects the 1604 ESM. So just a hunch, but again, another reason to try multiple tools depending on what operating systems you're using and seeing how your results vary. All right, so I had promised, and I'd like to keep my promises. So this is going back to that critical finding. And again, remember that for every finding you have, you're going to have to spend some time analyzing. So just to give you an example, so if you've got one critical finding, well, maybe it's going to take you a half hour, an hour to go dig through CVEs and packages and find out. If you have, 8 or 21, and they're like, we can't update it, we got to make it secure. Now you've got some substantial work to start documenting what is really there, right? Because we can't just say, oh, it's got 21, it's bad, right? If we could start finding false positives and get them out of the way, if we could find mitigations, or find out the thing's got web packages installed and it doesn't need to be a web server. What can we remove? That term that I always tell my students, Mary knows this, words to use to sound smart when you're at like the SCaLE conference, like, oh, we need to reduce the attack surface, right? All those cool little terms we like to throw around, that starts coming into play here. So here we are, we're just gonna look at our one critical, and we will drill down into some of these packages. But what it comes down to is that this one finding had 3 CVEs And I have to define CVE once a week to my manager, and I'm not even making that up. And he's like, let me write that down. And I'm like, well, write it down the same place as last time. We won't have this discussion again. And I was saying the wrong thing for the longest time. I mean, if you've ever, okay, how many people have been to DEF CON? Good number of you, right? In a drunk hacker Jeopardy, which I really want to do, but I don't drink. And I know the guy who runs it, so I'm going to ask him one year if I could have a designated drinker. You're like, I get it wrong, my friend drinks. But they'll ask things like, what is CVE? Is there anyone, does everyone here think they could tell me what CVE stands for? You'll drink for me? Okay, I've got a new friend. I notice you've got a drink in your hand and you're leaning against the wall, so you're off to a good start. So CVE, and I always used to think it was like common, or I used to like think it was computer vulnerabilities, exploits, right? That sounds like a good mean. It's common vulnerabilities and exposures. It's like the worst acronym for what it is actually documenting, but CVE is tracking all the vulnerabilities that are out there. So there are actually 3 CVEs associated with this one finding. So now, wait, there's more. So we have to go dig into that. And if you go look into that, it will say, okay, this is the package version that needs to be on there. So just to give that a little more, I feel like a optometrist. Better now? Worse now? Better now? Okay, other eye. So we've got these 3 CVEs, and I found out that one of them says, okay, or not one of them, but all of them are resolved if you have the right package in there. Now, I don't know why Nessus didn't determine that package was in there. One of the things, and in my day job, this has been my life, right? Going, and especially before Nessus started detecting ESM packages. And it wasn't even Nessus's fault. So it turns out that when Canonical provides a list of updated packages, they were not giving the names that included ESM out to the world in the oval format that all the vulnerability management tools use to import and make their plugins. So it wasn't even Nessus's fault. Turns out it was Canonical. So sometimes it wasn't finding tools with package names with ESM in it. So I had to do a lot of manual reviews. And this is an example. The package is actually there. It's a false positive, and you can have the warm fuzzies that, in fact, it's funny. Like, so I actually had an anxiety dream about this presentation the other night. Good news for you, I am wearing all my clothes. And right, thumbs up, Carl, is everything good? And then I actually had to, because this guy just walked out and reminded me, it's like people just like totally walked out of my conference and like said, this is like a total waste of time. And I'm like, oh, well, so far so good, thanks for staying. All right, so that was my results from February. Time check, please. Oh, seriously, oh my God, someone should. People need to shut me up. All right, so we really are close to the end. So 5 months later, this morning, I fired up everything, updated the plugin, said, let's look at the scans today. So one more round of challenge the audience. How many additional security updates do you think there are in 1604? Shout out numbers. 15, okay, relatively no numbers. Okay, let's just go to the surprise. There were 63 security updates in 1404 and 124 in 1604. Oh, important thing I neglected to mention earlier. Extended security maintenance only provides updates for critical and highs. If they feel generous, they might do a medium, but mediums and lows are not going to be addressed for the most part. So it's only highs and criticals. So you can see that there's a substantial number of updates since that time. So I did my scans again and created another graph. So now, in this case, this is only 1404. This is 1404 in February. This is 1404 in July. So you could see the general degradation if they're not receiving updates. And then even a little bit worse receiving ESM updates, because it's not their priority to do ESM updates. They even say that it's like back burner of supporting the current operating systems. And then next slide is the same thing for 16. And 16 is still nice and shiny for you Firefly fans, right? So nice and shiny. So ESM's looking good. The non-ESM system is slowly becoming a dumpster fire. All right, so quick analysis. ESM addresses your criticals and highs and is effective at doing that. Even with the ESM updates, 1404 is not aging well. And then, as I show, you've got to review the results. You can't just trust, right? Because we found that for that one ESM system was a false positive. But I do think that you could use these features or use a presentation such as this if you have to convince management that there is a reason for paying for this maintenance. And then I don't know what the difference is between my final analysis and summary, but like I said, you could use this type of process to do this cost-benefit analysis with your management, and then do this at regular intervals, right? So I did it 5 months later, and I saw a definite trend in both 1604 and 1404. And then what I would like to do next, not right now with all of you, but what I'd like to do next with this is do a more thorough analysis with Rapid7, since I was getting, Rapid7 was finding more 1404 findings than Nessus. So I'd like to dig into that a little more. There's my contact information. I also teach at Long Beach City College, so you can always find me there. Thank you so much for your time. I do want to do a shameless plug for two people who are here, Adam and Marie, my friend's children, and they were giving a presentation 12:30 tomorrow. Quick plug, what is the topic? Customizing VM for use in cyber defense competitions, right? So if you got any kids who are doing like Cyber Patriot, National Cyber League, anything like that, go see them and make them really nervous and stare at them. Thank you so much for your time. I will hang out here if anyone's got any questions or we want to talk about old technology, and I hope you enjoy the rest of the conference and stay safe.
You went there, you ran away, little chicken. Whoa, whoa, sorry, sorry. Let me see if that works. That's okay, right? You can hear okay? Okay, cool. Kill y'all, because I know it's gonna kill y'all. And I pop my peas too, so. Eek. Okay, I think we're.
The sound can be remotely controlled from the room.
Mhm.
So if it sounds like adjust it.
Oh yeah, I was supposed to say person in the AV room, I'm very, very sorry. Please pan back because the chances of me standing still are probably like negative 100. So, I mean, I can tell you now I'm not going to, so please just. Well, I got told that they have to control it and like try to follow them, and no. It's gonna be fun, guys. It's gonna be fun. Or y'all. I'm gonna go with y'all. You have to be gender neutral. Y'all. Y'alls and you alls. Proper way to conjugate all that. Oh wait, I don't have my notes up anymore. I use my notes, don't judge me. Yes, for those that came in, we know it doesn't quite fill the thing, but you should have been here trying to get us to figure out how to put that on the screen, so we're just gonna pretend, just cut the left side off in your brains. Now that's all they're gonna focus on. I don't have to worry about you judging my talk. All right, I think we're about time, right? I've killed 6 minutes and 43 seconds according to this. All right, last person coming in. Okay. So thank you all for coming to my talk, APT's Transition to Linux. I know that's like the general way you're supposed to greet people, like, thank you for coming to my talk, but I really mean it. First of all, the fact that you showed up, so I'm not talking to an empty room, that means a lot. But 2 years ago, just with everything that happened, I had to leave the Linux world. It was a very hard decision for me to make, but at some point it's feed your kids or do what you love, and you're gonna go with feed your kids, hopefully. And so being here and getting to present in front of all of you is, like, it's a homecoming to me, and so I'm so excited. But a lot of you probably don't know me, except for my friends who are kind enough to come to the front row. So my name is Elle Marquez, and I'm a senior technical trainer and as well as a researcher over at a company called Grim. I'm also nervous, so just go with it. Normally, that's all I would say, and I would walk away from this slide, but I think what I do is really important for you to understand the research that you're gonna be seeing today. And that's because I get to take my trainer hat off, all cells, and just put it away, and then I get to go to a dark room at my house and hit the white papers, and just find a rabbit hole that interests me and chase that rabbit till it comes to an end and dig into another one. And as long as I'm passionate about what I'm learning, they don't care. Just come up with something. So my entire job is to go do this, tie it up in a nice little bow, come over here and present to you to give you actionable steps that you can take into your company and do tomorrow, even if you haven't had the time to do the research. On that, I want to give the biggest thank yous to two individuals. Nicole Fishman, they've worked with the IDF for over 6 years, the Israeli Defense Force, as well as working on getting new Linux malware variants and new undetected malware just as a whole. Specifically, her thing that she loves is Linux. So Miko is an interesting thing. I, as you can tell already, am really nervous because this is my research, and it's one of the first times that I've gotten to present it. Also, along the way, I was spitballing at people. You do peer reviews, you talk to people, and I had a lot of people tell me I was going down the wrong rabbit hole, that I was wrong, that I wasn't going to find the findings that I wanted, and I was terrified because I already committed to doing this talk. And so finally, Miko is the F-Secure head researcher. He's famous in his own right. Go Google him. He's pretty big up there. I didn't know him, but I knew he was good, so I just messaged him. And much to everybody freaking out, went, Miko, I need your help. This is the research that I've done. Could you please review it? And he took the time and he talked to me. He gave me some of his research. So the reason I take the time to say all this is thank you, because I'm not standing out here by myself. Right now, I'm standing on the shoulders of giants. And I really hope they listen to it. Okay, not gonna get emotional. Okay, so today what I'm going to do is I'm going to address an elephant in the room, and I truly hope that that elephant isn't in here. Seriously, I really do. But it hasn't happened yet, because the talk that I think you're expecting to get is not the talk that you're going to get. And you may disagree with me, and everybody says, Elle, don't say this in a presentation, but I am not a standard presenter. If you disagree with me, that's fine. That is the beauty of research, that you can establish your own beliefs and take into your company what it is that you need. So even if you don't agree with my premise, please stay and listen to the research itself, because it's going to help you. I'm going to do this in a form as a story, and this is where I start talking. I'm going to walking. This is where I'm going to take you on a trip to the past, because I firmly believe that if you don't understand your past, even in technology, there is absolutely no way you can defend in the future. Then we're going to go to the present, because if you don't understand what's going on right now, you will not build a secure path to the future. On that, I'm gonna drop some truth bombs. I'm gonna be not completely honest with you all, because if I'm holding back my punches, I'm not helping you at all. So at some points, I'm gonna call out the flaws in Linux, and you know what, get over it. We all know that it's not secure by default, and if that's shocking to you, please talk to me after this talk, because we have some serious conversations we need to have. With that being said, we're gonna go to poll the audience. Please, please, please be interactive, or this presentation is gonna be really boring. So, who here believes that a nation state is what an APT is? Well, all right, first time I haven't had, yeah, okay. Who here believes that organized crime should be brought into the definition of an APT? Organized crime and a nation state. Don't just nod, raise your hand, thank you. And who here believes that a hacktivist should actually be brought into it? So nation state, organized crime, and hacktivist. All right, so I had like 90% of you not know what it is, but that's okay, we're gonna be working together. All right, so I understand why people believe that it's a nation state, and actually that was the original definition. It was brought on by militaries referring to other militaries as the nation state type of attack. I worked at a company before where 99.1%, and I'm making up that statistic, but that's what it felt like, came from the Israeli army. And I had a few, I'm gonna go with heated discussions on this topic, and they were firm in their belief that I was 100% wrong, that nation states were the only thing that could truly be an APT. So then I went and talked to Miko about this, and he said actually 98% of the malware that's analyzed by F-Secure, and they're one of the biggest researchers when it comes to malware, is actually attributed to organized crime. And more, we're seeing hacktivists be successful in their attacks because they're able to bring in advanced tactics that we normally didn't think that they had. But this is where I differ, and this is where I go to the talk that probably all of you didn't know you wanted to attend. And that's what I disagree with every single one of those definitions of what an APT is. I think what those groups are their cybercrime unicorns. And I stole this from Miko, I'm gonna admit it, but I think it was adorable, so we're going with it. And what it is these groups are people who have been able to receive funding in order to attack in an advanced way. I mean, we've got nation states, of course they've got funding, they take it from their citizens, and whether their citizens know or not, it goes to fund military operations. Those military operations are jobs. They have a 9 to 5, probably longer, in which they develop malware, in which they get a way to be able to attack a system in a way that we haven't expected before. But we also have organized crime. And yes, organized crime sometimes gets their funding from nation states, but other times they can start small. I do a little campaign, get a few $100s. They are businesses. They reinvest their capital into their business. They attack again, get successful, reinvent their tactics, and they just keep doing that to the point where they can hire their own attackers, their own malware developers, and continue to include their code base to get stronger and stronger in a way that we don't reinvest in our companies as well as they do. And that brings me to what I believe the definition of an APT is. It's exactly what it's meant to be. APT stands for Advanced Persistent Threats. An APT is any attack, regardless of who has launched it, that is persistent. And by that, I don't mean they keep going after you. I mean, it could be that, but it's also that they've established persistence in your system, as well as a viable threat. And the reason that I say viable threat is too many times we say, oh, Cozy Bear or Fuzzy Bear or whatever Bear Russian APT that you want to talk about. They're the threat. Why? Why are they a threat? They can exist all they want to. If they're just sitting on the sidelines going, we've made enough money, we're good. It's not till they launch that attack. It's not till they take actual action that they become an APT. And I think unless we begin to understand that and understand that the threat itself is the unauthorized code or the malware that occurs, we cannot even begin to defend against true attacks. So in order to show that, I want to go to a journey in the past. And this is where I start just kind of being honest, y'all. Most of us, and I'm Texan, so y'all, most of us are not Linux enthusiasts. We're Linux zealots. We see Linux as this different beast. We're not like Windows. We're different. We're open source. People can look at our code. We're a community. We're strong together. Cool, great. Attacks are still working. Good job on the community. We have to be realistic to what we're doing. As a community, we need to accept that Linux is vulnerable and that these attacks are going to continue to happen. How can I prove that? Well, I'm going to take us back to 1971 with the advent of pushing a button, with the advent of the creeper worm. Now, the creeper worm is actually just known throughout the community to be the first piece of malware to ever attack a system. And I'm going to read this to you so I make sure I get it right. It specifically targeted the DEC PDP 10 mainframe computer running 10x operating system using ARPANET and spread through floppy disks. There you go. There's all the English you needed to get there. The reason that I took the time to read that is think about how specialized that worm was. Why was it that specialized? Because there was a community that believed that that mainframe was secure by default. So somebody created a piece of malware not to be malicious, but to prove to them that it wasn't. So walk with me a little bit further up into history to 1986 with Brain.A. Brain.A is recognized as the first virus that attacked an IBM PC, the first PC that we had. And the thing is, it was a proof of concept virus. People were like, ooh, I've got a PC, these things are so secure. And that really was a concept that we had. So two brothers, Amahad Farou Alaviv and Basti Farou Alaviv, wrote a proof of concept virus to prove to people that PC was definitely not secure. Now, how can I give that attribution? I wasn't giving the attribution because I spoke to another researcher. Frankly, I didn't have to do much research. Oops. All I had to do is click the right slide. All I had to do was look at the code itself. They gave themselves attribution. This wasn't meant to be malicious. All they wanted to prove is the security flaws. Funny story though, okay? So 25 years after Miko found this piece of malware, he goes, I really want to meet the people who wrote this. Like, wouldn't that be cool if I did? So I believe InfoSec is 6 degrees of separation. And really, that's how I found Miko, right? You know somebody who knows somebody. And so he put it out there, and 2 days later, the brothers contact him back and say, it would be great to meet you. Here's our address. That's the address they gave him. They still live there. He could have shown up. So what do you do with that, right? You jump on a plane and you go to Pakistan. So I'd introduce you to the two brothers who wrote the first piece of malware that infected a PC. So at this point, I've walked you through and you understand that mainframes were vulnerable. Obviously, right? We're like, duh, history has taught us that. PCs are vulnerable. Well, I think a lot of us in this room have made that judgment already. So why in the world did we ever have the belief that Linux was secure by default? And if you're sitting going, I never believed that, bull. Those people in front of us, those people who came before us, that was a real opinion that they had. If you never believed that, it's because you were never told it and you were in this industry after that mindset. So I'm just going to call y'all on that. And me too. I was told that to begin with, and I truly believed it. So that brings us to 1986 in Stog. Now, I'm going to probably say it wrong. Stog, whatever. It was, if anybody knows, please tell me. But it is believed to be the first Linux virus to ever actually be out there, to ever be found. And I don't understand why we didn't see it coming. Like, we saw it in the mainframe. We saw it in Windows. Like, duh, we should have been prepared for this. Our defenses should have already been ready, because guess what it was? Just like the other two, it was a worm. Now here are some strings that we were able to pull out of the code. And the one that I underlined it is my favorite because it did a better job of system administration than we do. It went, are you up to date? Oh no, you're an older version of me. Let me update you. And if it wasn't infected, it went ahead and infected it. And it was actually, what was I going to say? It was an actually interesting story. Okay, so on February 5th, the creator of SCaLE came out and he was like, y'all, I think I messed up on a mailing list. He's like, this thing has gotten out of hand. It has gone further than I ever thought it was going to. My bad. That night, McAfee came out and he was, y'all can't believe what I just found. I just discovered a brand new piece of variant called SCaLE. So, I mean, I guess if you read a mailing list and you find something new, technically you discovered it. I always find that, I always find John McAfee stories interesting. So, funny there. Those who know him. Next takes me to 2001. So, 2001, we had a brand new piece of malware called Ramen. By 2001, Linux had become a big target, a fast-growing target for virus developers, because we still didn't have the security in place that we needed to. Ramen targeted specifically Red Hat systems running web servers. Now, running as a web server? Why do I bring that up? Because historically, we should have already known as we walk through this that malware was going to be written in such a way that it came to a specific target. It was a fun piece of malware. It didn't do too much. It went in and defaced the site and said, hackers love noodles. And let me tell you, as a hacker, we do love noodles. So one of the notable, and I have to say this just because I'm Texas, two of the notable victims were NASA in Houston and Texas A&M right down the road. So, just saying. I'm not an Aggie, just in case anyone wondered where that came from. All right, so it was one of the first pieces of friendly malware. I love friendly malware. Friendly malware, I love malware. It's a wrong thing. I hate what malware does, but I love malware itself. Like, I'm just going to own that. But what it did is once it went in and it defaced the website, I mean, come on, is it really that bad? You could bring your website. It's not that bad of a virus. But then it would go and it would patch the way that the exploit that allowed it to come in. It's a nice little virus. But so now I've gone through, we've gone through the mainframe, we've gone through the PC, we've gone through Linux. What's next? Where am I going to go? Cross-platform malware. Yeah, we've walked this road. How the hell, and I'm going to go with that, sorry people if you have to blur that out, how the hell were we not ready for this? How did we not think that this is where we were going? And cross-platform malware comes from the fact that we were all lazy. Straight up. If you're a Linux person, you're lazy. You will spend 2 hours automating something that you could have fixed in 2 seconds. That's just the way we are. We don't say lazy. We say clever, ingenuitive, whatever. We're lazy. So we're developers. If you're a developer in this room, I'm sorry, but my friend Corey says something. He says there are front-end developers and there are back-end developers. And then the rest of us who are Stack Overflow developers. Why? I love him. Well, why are we going to take the time to write a new code base when it's right there? Just pick it up, shift it, put it in, it's going to work. Why am I going to take the time to tailor Linux malware, tailor Mac OS malware, tailor Windows malware when just take the code, put it on each one and it works. It makes sense. So Bad Bunny was a ransomware worm, there you go. And like I said, it attacked all variants. Here's the part that I find interesting and the part that honestly makes me a little mad. I'm an emotional presenter. And that's that Bad Bunny was discovered in 2017 and was attributed by Malwarebytes to likely have been created by the authors of Petya and NotPetya. If you don't know about these two pieces of malware, write them freaking down right now, and as soon as you walk out of that room, go and read about them. These were critical pieces of ransomware that brought countries down to their knees. We watched this happen. We watched the devastation happen to it. We watched this ransomware tear through entire civilizations. Why the hell weren't we ready for it when it came to Linux? Did we think that we were that special? Because Petya targeted critical infrastructure for countries. Guess what Bad Bunny did? Bad Bunny targeted nation states, targeting their critical infrastructure, having the exact same results as Petya and NotPetya. Yet Linux was special, and we weren't ready. Told you guys we're going to drop some truth bombs today. That brings me down to IP Storm. We're getting closer to modern day. We're getting closer to the present, I promise. IP Storm, though it says on there 2020, let's build a story, was actually found in 2019 as a Windows piece of malware, targeting the interplanetary file system as a peer-to-peer network. It's a tongue twister for me. And so it was named IP Storm by the researchers. By 2020, my friend Nicole, she's my bestie now, and Abigail Mencher, I call her Abby, actually found a brand new variant of IP Storm. So 1 year later, they found a brand new variant of that exact same malware using a lot of the same code base running on Linux. A month later, they found it on Mac OS. Because it was a Windows virus, Why would we list? I mean, that's Windows. I mean, that doesn't matter in the Linux world, right? We all know they have viruses. Y'all, they lift and shifted that virus right over to us. That should terrify us, the fact that we knew the code was out there, that we knew what it did, we knew its signature, we knew its anomaly, and it still worked on our systems. And one of the things that I got, so when I worked at Inazur, which is the company that they're at, I got so tired of saying this. It was to the point where I said it so much at a conference that I just rolled my eyes. So when IP Storm was found, it had 0% detection on virus total, and so has maybe 99% of the Linux malware that I've talked about. It's not working. Our security practices are not working. Put it out there. We need to accept that it's not working, and we need to start from that point when we're building our defenses, maybe meaning that we should pay attention to the history. Now, I've actually built in a water break for myself, because as y'all can tell, I talk a lot and I talk really fast. So I wanted to put this up there, and maybe I won't. I can kind of see it. I can share my slides later on because it shows how many of the shared features happened between two variants. Y'all give me a minute, please. I'm shaking. All right, so I will share my slides so you can see this. But when I say they lift and shifted code, this was written in Golang, which is a cross-platform piece of malware, yeah, scripting language. So literally, the code was right there. It's nothing new. It's nothing we shouldn't have seen. So that brings me to my present. And I've talked a lot about Windows and everything else, and hopefully you'll understand what it is that I'm saying when it comes to an APT. Because at a certain point, maybe these attacks aren't even that advanced. They're advanced because we allow them to be, because we don't put the right security in place. So let's go into why I decided to talk about this to Linux, because I do think it's important, and I think it's something that we don't think about, though I'll cover some of the bases that we do. Why Linux? Did you all know that China has its own version of Linux? How about the Turkish government? That the Russian government uses Linux? That should be really big in the news right now, because you're going to see that in the cyber attacks that are happening. Did you know in 2001, the White House moved over to Linux? Did you know that the Austrian capital uses Linux? That in 2004, the Venezuela government moved over to Linux. Why Linux? If you believe that a nation state is an APT, that's why Linux. Because an APT is going to be used from a nation state against another nation state. And how many of you think that the White House sat down with everybody and offered proper Linux security training before transitioning into it? I'll go with probably not. So they're already going to know where our defenses are going to be weak, and they're going to go after them. Why Linux? The cloud. And yeah, everybody's probably rolling their eyes. Okay, you can skip this slide. We all know, hey, what are Linux servers? But what is the cloud made out of? Linux servers. We all know that joke. I think this is a huge issue that we're not paying attention to, and this is going to be one of the primary reasons that APTs are going to continue to grow and be successful. Because how are we transitioning to the cloud? As quickly as humanly possible. That's where the money is. We don't need to worry about security in the cloud. Y'all, AWS is going to do that for us. We can just, after all, we're responsible for what's in the cloud. They're responsible for the cloud itself. I call that, and I stole this from somebody, but I don't remember who, the cloud irresponsibility model, because it's a joke. We tell developers, hey, go use serverless technology, use Lambda, use Azure Functions, and security is just built in that. They're doing it. Both of those have officially been breached. And go look up the article called We Hacked Azure Functions by Inazur. You know the advanced technology that we use to hack that? Netcat. One command. So yeah, the cloud is secure by default. I can only imagine what not friendly researchers could have done with that. It's terrifying to me. And we're transitioning without training. A lot of things here make me mad, as you all can tell. I've spent time speaking to hundreds and hundreds of developers and hundreds of Linux and security individuals. What makes me mad is their jobs are going away because they're being outsourced to the cloud. More and more security positions are being left not filled because the cloud provider can do that for them. How much training do you think the developers have received in Linux security? We're just told, hey, make sure that you make more secure code. That's literally the training that they get. So now we have to provide them with training with Linux. By the way, they also need to be trained in the cloud. It doesn't matter that the cloud provider is running Linux because half the time you're pushing buttons on there. According to Gardner and Sands, 70% of vulnerabilities occur on the application level. So developers in the room might want to get on that, write some more secure code. I know that's what you all are told. And 80% of attacks are successful in the cloud because of misconfigurations. Why Linux? Because it's easy to breach. Now let's go over to why Linux smart cars. We all have smart cars, right? So Grim has a division that is dedicated to smart cars, and y'all, I don't want to say their jobs are easy. Like, I'm sure they work really hard, but how easily they complete a task shocks me. I want to go work in that division because I can have results. It's not like writing training where it takes me a few months. Give me an hour, I'll have something on a smart car. It's just crazy, so much so that the Federal Bureau of Investigation came out and said, hey, smart car builders, could you do us a favor? And I really wish this didn't read this way, but could you do us a favor? Could you build your cars with cybersecurity in mind? The fact that that had to be asked by the federal government just freaks me out. One of the things is there has to be absolutely no in-person contact with the car. In fact, a researcher in Germany recently was able to breach 25 different Teslas around the world without ever even seeing them. That should scare you, because do you know how many cars that you might not even think of, they're not Teslas, but your car has some smart functions. Who's using, the Intune audio system or any of that? None of that is secure, right? I've got it too. I wanted to figure out how to unplug it, because I can promise you it's not going through any type of secure tunneling. I've used the app, neither is that. App developers. Sorry, I just met a new friend who's an app developer. He told me horror stories. So why Linux? Smartphones. And once again, this might be something like, yeah, okay, Android can be hit by viruses. We know that. Just move on. Okay, if you guys are going to accept that, that's great. Android is inherently really unsecure. But what do we tell? Hey, mom, dad, grandma, why don't you use this iPhone? iPhones are more secure, right? It's going to cringe. They're secure by default. Apple does a great job of vetting what's in there. All right, yeah, secure by default should be scaring you at this point. But let me introduce you to Pegasus. Pegasus was created by the NSO group. I trip up when I talk about the NSO group because there are certain parties and organizations who have deemed them to be a threat group. They themselves do not believe they are a threat group. They believe that they are a malware as a service company, providing a service to help being able to promote diplomacy and, diplomacy throughout the world. They want to ensure that governments can ensure the safety of their people. Do your own research. I'm here as a researcher, not someone to cast votes on what's occurring. So please do your own research, make up your own mind. But they've been able to develop Pegasus, which can go into an iPhone and break its encryption and make everything clear text. This isn't it's a proof of concept. This is occurring and has happened. So much so that the Federal Bureau of Investigation, I just need to start saying the FBI, I hate acronyms. But the FBI has actually gone in and purchased a license for Pegasus. You don't purchase Pegasus, you purchase a license. And if the NSO believes that you're doing something bad, they'll revoke that license from you. So once again, you decide. But they actually, it is believed when it came out that they were gonna use this for domestic surveillance. Is that good or bad? Well, for domestic surveillance, the Mexican government recently used it to capture El Chapo, one of the world's biggest drug lords. So if you don't know much about Pegasus, please go and research it. It's really interesting. The reason that I bring this up, even though it's on iPhones, is why are we still in the mindset right now that something is secure? Like, iPhones are not secure by default. Just because we don't know what's out there doesn't mean it's not out there. We didn't know about Pegasus for a while. And why am I bringing it up? Because what part of us doesn't think this is going to lift and shift? The style of attack, how strong this attack is going to lift and shift to move over to Linux. Yeah, I'm using Signal. It's all encrypted, right? I'm using Telegram. It's all encrypted until the next variant of malware comes out and proves you wrong. So why Linux? I'm being so negative today. The cloud, we've covered it. The cars, we've covered it. Smartphones, we've covered it. Did you know that Chromebooks are actually outselling MacBooks at this point? SpaceX, yay, we're sending Linux to space. We're already out there. Most people didn't know Mars rover, by the way, sings itself happy birthday. Poor little robot. It was running Linux. IoT devices, I almost left this off this slide because I have an 8-hour workshop on the flaws and vulnerabilities inside of IoT devices. I could give a 3-hour talk about talking at this pacing and not stopping about how horrendous security is in it. But then you would all wonder, why didn't you include IoT devices? Did you not know about that? If you don't know the inherent risks of IoT devices, I recommend a book that Miko wrote called If It's Smart, It's Vulnerable. Or just go in and type in IoT security and be prepared to take every smart device out of your house. I wish I was kidding. If you want any advice on how to move that to its own VLAN, not related to this talk, please talk to me. It needs to be segregated, especially if you have kids. Okay, off my high horse there. So why Linux? I can actually bring this down to one sentence. And I'm stealing it from Billy Sutton, who was a very well-renowned, well-known bank robber. So when he was asked, why rob banks? Because that's where the money is. Why rob Linux? Because that's where the money is. Now, some of you did vote that organized crime could be a form of an APT. So let's talk about Team TNT. Now, Team TNT was officially announced as a threat group by MITRE recently. FYI, I called them an APT long before that. You know, just putting that out there. That's my street cred. Team TNT is a threat group that's primarily targeted cloud and Linux environments, specifically containerized environments. A bit of transparency here. We're Twitter friends. I always say we're friends, but I have to specify we're Twitter friends. And the way that this came about is they are very open on Twitter. You have a question, you've done research, they'll tell you. And a few researchers attributed research to them that wasn't it, and they straight up called them out, like, you guys are wrong, you need to do your jobs better. So they recently announced that they were gonna go under. Like, it was too close, Interpol was too close, they're done, they're going. And I said, wait, before you guys leave, do me a favor. I don't want to misattribute you. Could you read my research and tell me, if it's good? Worst they could have said is, well, actually, worst they could have done is a lot of stuff. But the worst in my mind at that time was they could have said no. But they read my research, and they came back to me, and they posed this interesting question to me. And I want to know what you all would say. With the mindset of a researcher, they asked me, do you believe that we're criminals? And I said, well, I don't know how to answer that. I don't know what you mean. They said, the only thing that we've done is gone into an environment that was configured to accept connections, that was configured and expecting to accept connections from the outside world. What were they saying? The only thing that they'd attacked was misconfigured Docker containers. Is it a crime to go to a place where they're already accepting people to come in? Now, I'm not here to talk about what they did after to judge. I'm here as a researcher, and I understand what they're saying, and I'm here to present to you what they talked to me about. We're such good friends, y'all, that they believe in my It's Okay to Be New campaign. I've got stickers, too, if anybody wants it. Hopefully they don't mean it's okay to be a new crime group, but, whatever. I just thought I was special, and they retweeted me. So let's talk about Team TNT. Now, they've been active since 2019 attacking Redis servers. I call them a cloud and Linux native attacker. I think that's awesome. They were born in the cloud, they were raised in the cloud, they've attacked in the cloud. I will go back and forth saying what they do and what they did, because they said they were going under and then they did some more things. So whether they're retired or not, we're just gonna have to keep watching to see. Interesting story in just a second on what they came back to do. So I should have, just ignore Docky. That was something else I was going to go off on a tangent, but decided not to. But they use actively tried and trusted compiled binaries. What do I mean by that? I mean, we should know already what they're doing. They go out there and they find open source malware that's available on GitHub, and they steal some of it, and they put it into their code, and they make it work. Stuff that's been out there. What Mirai was, 2016, 2006, that it was just completely just put on GitHub? That code still works and is able to bypass our detection on Linux, by the way. Like, we need to pay closer attention. And how do I know? Because you go and, I'm going to skip one for a second here. Team TNT is an open source contributor. They are an open source attacker. They take the scripts, they bring it in, and they contribute it back to the community. You know what? We tell how great open source is, so they tout open source as well. They also take Windows-based tools such as Mimikatz, stuff that Mimikatz was one of the things that when I got into security, I learned to use it, 3 weeks in? It's not that powerful of a tool except for the fact that it is. The reason I say it's not that powerful tool is because we should be prepared for it. We should know how it works. So what happens, they relabel it MimiPy, make it work on Linux, and suddenly it's a great tool again. Y'all, this is getting a little bit ridiculous if you can go with me here. Now, where I was going to go is, I told you we'd talked a few times, and I've told you I have favorite kinds of malware. My favorite malware in the whole wide world that holds a piece of my heart is Lemon Duck. Team TNT recently came back attacking containers with Lemon Duck. Now, I didn't tell them this, so I really don't think I had any place to play in it, but when I first saw it, I went, oh, hell. Can I talk to our legal department real quick? But no, I had no part in it. But the reason that Lemon Duck is my favorite piece of malware is, y'all, he is the best system administrator you could ever have. He is so much better than 90% of the sysadmins that I know. Because he goes to an environment, he cleans house. He goes, is there any other crypto mining software on here? You're out. I'm going to clean you up. I'm going to get you out of here. And then, how did they get in? What did they exploit? all of that's going to be saved. How are your resources going? You know what? We can fix this a little better, make things go a little better. Are we updated? Let's update this stuff too. He does such a good job, and all he wants out of that is to be able to do some crypto mining. Look, he wants to get paid. So do the rest of us. Hopefully y'all know I'm being sarcastic, but he is a great little piece of malware. I actually have heard stories of systems that were actually attacked by malware such as LemonDuck, that it did such a great job that they decided to allow the attackers to stay in the environment. There's a Darknet Diaries, I forget the name, of a windmill farm that was attacked, but the windmills got such great ability to be able to pass power after they were attacked that they just went, all right, you're hired as our sysadmins, and let it stay. So you do with that what you're going to do. Now, LemonDuck is continuously being updated. It's been around for a while, since 2019. The reason that it's one of my favorites is that every single time, I swear, that I see a new variant, it has new abilities to it. It's still working. 2019, all they've done is add new abilities, but guess what? They add a new ability, they go past our anomaly-based detection. They add a new ability, they've changed some code, they bypass our signature-based detection. Like I said, 0% detection on virus total. Now, as a part of it, it was originally a cryptocurrency miner, and then it went to a botnet, and now, and I wrote it down, it now steals and removes security controls. It has a stronger C2, a command and control server. It has learned, my little duck has learned how to go and protect other systems, pivot, make sure that all the network is safe. Good little duck. And it ultimately has been human friendly. It goes and it drops tools that other people can come in and make sure the system is secure. It's insane, but that's actually what's happening. They will go in and fix your resources so they can get better crypto mining going on. LemonDuck currently works on Windows, Linux, and has recently been seen transferring to edge things such as Wi-Fi routers. I've been droning on, so now let's go to the future. What is the future? Well, I'm excited to announce to you that the future is now LemonCat. I kid you not. So as malware is developed, like I said, why would we reinvent the wheel? People are taking code out of LemonDuck, and they've changed LemonDuck as the variable and named it LemonCat. And that's how they're doing it to bring in new malware. Why is this effective? I just, literally go and make sure that your systems are protected. Maybe the best way to see if your system is breached, is if it's running better than it ever has before. And I wish I was joking. So start looking for things like, would you ever have thought to monitor for that? It sounds ridiculous, but that's what attackers are doing. That is the future. They want to hide, they want to establish persistence in a way that you might not even mind, things that you're not going to be actually looking for. So LemonCat is our new nice kitty. Now, I had a lot of different things that I could talk about, and I really wanted to boil it down to what I thought would really be impactful. What do I see the future being? Ransomware. Without a doubt. How do I know that? Because I pay attention to what's happening in the Windows world. I don't have a question about the fact that this is our future. Now, I never assume that anyone knows everything, because Lord knows that I don't. So I'm going to go over different types of ransomware really quickly. First of all, there's crypto ransomware. This is what a lot of us on the Linux side are familiar with, where they go in and they lock down a system and they say, we're not going to give you your information back unless you pay us this amount of money. We'll give you the keys. You can get your information back. Lockers are what most people are know about. So, in the movie where the good guy goes and he sits down and he opens his computer and there's this huge skull and crossbones with, all this, pay us this amount of money or you'll never see your data again. That's what lockerware is. Doxware is one of the things that scares me the most. My partner and I have both been targets of doxing, to the point where I had to move, and he has more security cameras than I had ever cared to admit. Doxware is terrifying, and that's where they either find something about you, they lock down your information, they lock down your PC, and they say, if you don't pay, we are going to leak your personal information. This could be anything: where you live, where your children go to school, call your parents up and start giving them information about your online activities, even videos that they've managed to get. It's a very scary, real thing. So I don't think that our future is going to just be Linux servers in the cloud. Linux boxes and the devices that you're using right now are going to be targets of Linux ransomware. We have leakware, which is very similar to Doxware, except what is the number one thing? To somebody, please tell me the number one thing that we tell companies to do to help prevent successful ransomware attacks. Somebody's got to know, come on. Train users, what else? Backups, right? Definitely, backups. Did you say 3? backup. So it said normal one, offline, and did you say off vacation? Off location. Sorry, I was like, what? It's on vacation, so it doesn't get updated. Okay, guess what? I work in the security field. I do. I know exactly what they're going to give you. Should I ever decide to be a little more friendly with my lemon duck, guess what I'm going to know that you do? First of all, I'm going to go after your backups, which is why they say, one that's offline. But second of all, before I do my ransomware, I'm going to exfiltrate your information. And it's gotten to the point where we all are like, okay, yeah, they're going to release my information, whatever. I mean, how many times has my password and my social security number been out there? I'll just change my password. It'll be fine. I hate that that's where we've gotten to. I mean, how many of you have been hit by the target breach about 4 times at this point? But what they're doing is imagine that you're a business and you are living on proprietary information. You have a brand new product that's going to come out that's going to make you millions. If that is leaked to your competitor, you're done. You might as well have paid the ransom because there is no money coming into you. It is terrifying. Now we have ransomware as a service. I'm actually going to come back to ransomware as a service because I'm going to geek out in it in just a minute. But what I would say with all of this, now that I've explained all of it, how the hell were we surprised that this was going to happen? Because let me take you back to 1989 with the first piece of ransomware. Wasn't that exciting? Like, it's been around for a while. And so the first piece of ransomware actually went to 1989. It was called the AIDS Trojan. It was created by a biologist named Joseph Pop. And what he did, he took 20,000 floppy disks, infected them with the AIDS virus. I'm sorry, the funny part is getting to a moment, so I just know. So he infected it with this virus and handed it out at the World Health Organization's AIDS conference. And with the disk, and I'm going to make sure to read this, the disk had a little label that was called AIDS Information and Introductory Diskette. But it came with the pamphlet. And on that pamphlet, it said that this would adversely affect other applications on your system. It also said that you will owe compensation and possible damages to the PC Cyborg Corporation, and that your computer would stop functioning as normal. The AIDS virus spread, even though having all of this information in the disk. I think he was looking to make a hacktivist point here, to my point that hacktivist organizations can be successful. Now, like I said, I'll make this available. I know it might be hard to see. But what it said is they have good customer service, y'all. I mean, all you needed to do was $189 sent to this P.O. box in Panama, and he would help you get your files back. And look, if you had more than one device infected, he wasn't going to make you pay $189 for every single one of them. Just send a one-time payment of $378, and we've got you covered. That brings me to my predictions and when I'm going to get to geek out over ransomware as a service. My prediction is that threat groups and ransomware as a service groups are going to become more user-friendly. So let me give you a true story, except I'm going to use myself as the example. Let's say that I'm an elderly person and I use my computer to stay up to date with my grandchildren. I have so many amazing pictures of my grandkids on here. Then I let my grandkid use the computer and it gets locked down by ransomware. What am I going to do? I don't understand how these things work. There's a 1-800 number here I can call. So I'm going to call the 1-800 number, and the person, I'm like, oh my God, my grandchildren's pictures, blah, blah. Calm down, ma'am. It's okay. What you need to do in order to get your files back is blah, 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 pay all this. But what is Bitcoin? Don't worry, we're going to walk you through this. And they walk you through the way to be able to purchase Bitcoin, to send it to them. And if you say, okay, I've sent you the money, but I don't know what to do now, it's okay, ma'am. I'm going to stay on the line, and I'm going to help you go through and unlock all the files that you need. This is a true story. This actually happens. And why is it such a big deal? Because if you already know that this threat group will make good on giving you back your information, are you not more likely to pay that ransom? One of the coolest parts, yes, we're going to geek out together on bad things. They're also user-friendly when it comes to other attackers. Okay, so imagine that you're a baby criminal organization and you don't know how to get started, but you know you want to be a bad guy. And you're going like, okay, how do I get started? I can make some money out of this, but I don't have the development power to do it. I'm going to go hire ransomware as a service. Well, I still don't really know how to do this. It's okay, they have a GUI. So you go in, you buy, you log in, and you look, and you're like, oh, what kind of ransomware do I want? Okay, I have the information that I want from my attacker, so I'm going to choose this one, put in my information. The ransomware group says, okay, you know what? And I'm making up numbers here because it just depends on the organization. Okay, we're going to help you through it. You're going to provide the information. You're the one taking on the responsibility for doing the attack. All we're doing is providing a tool that is for research. So you go in, you do your attack. You're going to get 80%, we'll get 20%, or maybe the other way around. They didn't do anything. They provided you a service, so you're going to pay them some money. And what do? You're a good business. You're going to reinvest. You're going to come back. I don't know if you can get it on Google. I don't remember how I found it, but go and try to find some of the documentation on this stuff. Their documentation on how to use ransomware as a service is better than 99.999% of open source documentation that I have seen. This is awesome. All right, so we're going to continue to see criminal unicorns continue to grow, reinvesting in money. We're going to continue to see code reuse. Why not? I think I've explained that through the whole thing. We're going to see an increase in cross-platform malware, because we're going to continue to see growth in scripting languages like Golang. We're going to continue to see attacks on managed service providers. Now, I have another talk on that, but I wanted to add this in here, because imagine if I got control of AWS. Imagine if I just got control of one hypervisor on AWS. Imagine if I got control over a managed security provider. Imagine what havoc I can wreak. Guess what is happening? And it's being effective, and it has happened. I stood on the stage at GERCON, I like showing this, and I said, imagine if the NSO group, imagine if the group that went in and did Log4j and did all these other things that I'm blanking on right now because I know I'm running out of time, went for AWS as a whole. You know what happened a month later? That same attack group went and hit AWS. Now, luckily, I do believe as far as I know, they were able to block it. They have absolutely no responsibility to tell you if it was successful. But anyways, and it's happening in other countries. Go, Google it, find out a lot of information. It'll terrify and not let you sleep at night. So we're also going to see malware developers shift their attack styles. That was one of the things that I keep saying. We work in security. There are good hackers like myself that will go in there and we will do bad things on your server to prove to you that it is possible and how to defend it. There are those of us, not me, that do this as a day job and now know what the hell's wrong with your system and will go home and know how to attack other people's devices, especially if they're running the same type of applications. We have to continue to stay not only one step ahead, but stay up to date what's happening on this exact moment. So I can't leave you without leaving you any advice now that I've told you all this bad stuff. Learn from the past. If you've learned nothing else here, nothing is ever new again. It's all continuous repetition. Don't plug in that USB because it might be infected. Guess what we used to say? Don't plug in that floppy disk, because it used to be infected. It's the same damn thing. Assume breach. I don't care if you're using a Linux desktop, a Linux server, whatever it is, what I want you to do when you're setting up your security controls is I want you to assume the attacker's already in your system. Too many times have I seen somebody clean up their system and start ignoring things because they've pushed the attacker out, and all the attacker did was establish persistence and is sitting there quietly waiting for you to go back to normal. Every single step that you use, even on your desktop, and I don't have time to go into it, Google the virus evil gnome if you don't think that we can completely own your laptop with a single piece of malware, and watch you get into all these other servers. Assume that we're already in there. Think like an attacker. How do you do that? It's actually quite simple. What is your company's business objective? I'm a security person. I'm a sysadmin. I don't care. I do my job. You should care. Because what if your company is about to release this brand new feature, brand new exciting feature? Back in the day, pretend we're back in time and they're going to go on Oprah, because I don't know who replaced Oprah. And we're just going to get inundated with traffic. This is going to be awesome. Guess what the attacker did? The attacker watched Oprah. The attacker knows that this is going to happen. We know your code's not going to be secure. It's the first deployment of it. You're probably rushed to make that deadline anyways. You're already expecting a ton of traffic. It's going to be easy for me to hide. If, let's say that your objective is to have proprietary information, you're making the new AI, guess what I'm going to go after? Guess what I'm going to do? I'm probably going to distract you on something else because I know that I'm hunting down that proprietary information. If you know what your company's trying to do to make money, then you're going to know where the attackers are going to go after. Now, there was a whole keynote that was about this, so you know what, go and watch Eva's talk. And it's know what is on your system, from applications to code. Because if you don't know what's running on your system, it's going to be 100% impossible for you to be able to defend it. I went over by 6 minutes, I think, but with that, thank you all very much. Remember, it's okay to be new, and I'm happy to answer any questions here or out in the hall.